Before time begins, there is darkness. Not the darkness of night, but an endless, formless void stretching beyond the reach of imagination. No stars, no galaxies, not even a glimmer of light, only a deep and silent expanse, without a whisper or motion. In this primordial silence, even time itself lies dormant, meaning nothing in the emptiness. To ask what came before this moment is to step into the realm of mystery. Time itself did not yet exist in any way we understand. Perhaps there was truly nothing, or perhaps a state beyond our comprehension. In this void of no time and no space, all that could be is condensed into an infinitesimal point of potential, hidden in the darkness of the void. Try to imagine it, all the matter and energy that will become the universe, every star, every planet, every atom, squeezed into a space smaller than a grain of sand. It is an existence on the cusp of reality, a moment where the very laws of physics as we know them are fused together in unity, no up or down, no before or after, only a singular waiting stillness. If an observer could be there, though none can exist yet, they would see nothing and hear nothing. It is a stillness so profound, it almost hums with anticipation. A quiet tension hangs in that void, as if the universe to be is holding its breath. Then, in an instant beyond measure, the silence is broken. From that single point of unimaginable potential bursts a brilliant flash. A sudden, incandescent bloom of energy surges outward, and time itself awakens and starts to flow. What was nowhere and nothing explodes into somewhere and something. The void that knew no light is flooded with it, a blinding, searing radiance, unfathomably bright, as the newborn universe expands from a point to the size of a galaxy and beyond in the blink of an eye. Space stretches and swells faster than any motion we will ever know, carrying with it the essence of all that will ever exist. Space surged outward so astonishingly that an entire cosmos grew from microscopic size to astronomical scale in a heartbeat, a burst of expansion known as cosmic inflation. In this first furious moment of creation, the very fabric of space is hurled outward like a balloon inflating in an instant. The young cosmos is hot, dense, and glowing, a storm of energy and particles erupting into being. What was once a tranquil nothingness becomes a churning ocean of light and heat. There is no sound, for sound cannot travel in the void. But if we could assign a sound to such an event, it might be the roar of a cosmic ocean, or the crescendo of an orchestra, tuning up for the grand symphony of existence. Almost immediately, this infant universe begins to change. As it expands, it cools, ever so slightly at first. The primordial light, initially so intense, starts to lose some of its blinding glare as space grows larger. In mere fractions of a second, forces and particles that were once unified begin to separate into what will later become familiar. Gravity, electromagnetism, the strong and weak nuclear forces, the fundamental threads that will govern stars and atoms, emerge from the chaos as distinct entities, weaving the framework of a new reality. Within the first heartbeat of time, tiny primordial particles flicker into existence from the energy, minuscule quarks and electrons, rushing about in the seething glow. the universe is still unimaginably hot and dense. A brilliant plasma where particles and antiparticles are born in pairs from the violent energy. Each time matter appears, its mirror image, antimatter, appears alongside it. Most of these pairs encounter each other almost at once and vanish in bursts of pure energy, annihilating each other in brilliant flashes. A balance of creation and destruction plays out on the smallest scales, a delicate dance between matter and antimatter filling the young cosmos. For a moment, it seems as if nothing stable can emerge from this firestorm. Everything that forms is swiftly undone in a mutual embrace of oblivion. But within that grand dance, by fate or chance, a tiny imbalance arises. For every billion particles of antimatter, there are 1,000,000,001 particles of matter. It is a seemingly insignificant skew, a slight favoring of matter, but it changes everything. That one extra particle in a billion does not find a partner to destroy it. Those lonely survivors, those infinitesimal few, will become the seeds of all the galaxies, stars, and planets to come. The universe's first great battle, matter versus antimatter, ends in the narrowest victory for matter. Had it been a perfect tie, no matter would have survived. The universe would be left with nothing but energy. But with matter's tiny win, a material cosmos can unfold. The lights and heat of annihilation fade, leaving behind a young cosmos filled with a thin, hot brew of particles, mostly the simplest pieces that will one day form atoms of hydrogen and helium. Time flows on. Seconds stretch into minutes, though in this early epoch, a second is an eternity of change. The newborn universe, once as small as a grain of sand, grows vastly larger, expanding and cooling with each passing moment. In the first few minutes, a new phenomenon unfolds: the formation of atomic nuclei. Protons and neutrons, themselves formed from smaller quarks just moments earlier, begin to bind together. In this furnace of creation, the simplest elements take shape. Most of the matter settles into the lightest element, hydrogen, a single proton at its heart. Some of those protons fuse with neutrons, forming helium nuclei. 2 protons and 2 neutrons bound together. A trace amount of lithium also emerges, a whisper of a heavier element in the mix. The basic recipe of matter is set: an overwhelming abundance of hydrogen, a dash of helium, and only the faintest sprinkling of anything else. The universe is still far too hot for these nuclei to capture electrons and become complete atoms, but the ingredients are in place. As minutes turn into hours and hours into thousands of years, the expansion continues relentlessly. The fireball of creation, once blindingly white, now cools through shades of yellow, then red, and into a dimmer orange glow. Hundreds of thousands of years slip by. What was once a seething, opaque plasma becomes cool enough that wandering electrons can finally slow down and settle. Those free electrons, which have been hurtling through space and ricocheting off protons, now find homes orbiting the nuclei that formed long before. Atoms, real, neutral atoms, form for the first time. Vast clouds of hydrogen and helium atoms come into being, like a cosmic mist cooling and condensing after a long storm. And when these atoms form, something magical happens. The intense light that filled the cosmos is suddenly free to travel. Before this moment, the universe was like an opaque fog. Photons, particles of light, could only move a tiny step before colliding with a free electron and scattering in a new direction, like headlights in thick fog. But now, as atoms capture those free electrons, the fog clears. The plasma transforms into a transparent gas. The brilliant afterglow of the Big Bang, once trapped everywhere in a bright fog, is released and bursts forth, racing across the expanding universe. This is the first light that ever shines freely through the cosmos. A blazing flash that marks the universe's dawn. Space is flooded with a bright, warm glow that will eventually cool and dim over billions of years. To this day, that very light continues its journey, stretched and chilled by the expansion of space until it has become a faint afterglow of microwaves filling the sky. The cosmic microwave background radiation. It is a gentle whisper from the fiery birth of the universe, still echoing all around us. Yet paradoxically, once this primordial light departs, the universe itself falls into darkness again. The brilliant glow of creation now streams outward, leaving behind an expanding space filled with matter, but bereft of new light sources. There are not yet any stars to shine. The stage is set with atoms, and the faint afterglow still glimmering in the distance. But the cosmic theatre waits in an unlit hush for its next act. The temperature has fallen dramatically. The once blistering furnace is now a cool, dark expanse. The sea of hydrogen and helium gas is almost uniformly spread out, thinning as the universe grows ever larger. To any hypothetical wanderer in this young cosmos, it would seem as though nothing is happening, a cold darkness stretching in all directions, punctuated only by the fading glow far off in the background. But in this darkness, all is not truly still. Invisible to any eye is the subtle but inexorable pull of gravity at work. Tiny imperfections in the once uniform gas, slight densifications here and there, become the seeds of structure. Where there is a touch more hydrogen in one region than in its surroundings, gravity begins to draw even more gas inward. Ever so gently, over countless years, the whisper of gravity amplifies these small clumps. Regions of gas that were once just a hair denser than their neighbours gradually grow into clouds, each pulling in more and more matter. What was diffuse and almost featureless begins to gather into filaments and clumps. The darkness is no longer completely empty. It is pregnant with possibility, filled with immense chilly clouds of hydrogen like invisible nebulae in the night. Time during these ages flows on a scale almost beyond human conception. Millions of years pass, then tens of millions. For tens of millions of years, the universe knows only darkness. It is a quiet interlude, a cosmic night after the first glow has faded and before the first stars have begun to shine. During this time, the primordial gas, cooled and calm, drifts and coalesces under gravity's persistent tug. The cosmos, like a sleeping embryo, is preparing for its next phase of development. In the great dark stretches, gravity works silently, drawing the diffuse gas into denser pockets. The stage is slowly being set in the secrecy of night. Deep in the densest of those growing clouds, something new and wonderful is on the horizon. Imagine an enormous cloud of gas and dust, dozens of light years across, gradually collapsing under its own weight. As the gas falls inward, what was once cold begins to heat up from compression. At the center of such a cloud, the material is squeezed so tightly and heated so intensely that a spark is about to ignite. In the cold darkness of the cosmic night, There are now places where, deep inside, it's becoming warm and bright, embers forming within vast, invisible clouds. At last, the long darkness ends with a brilliant dawn. The collapse of a gas cloud's core reaches a critical point. The temperature and pressure at the very center climb to incredible levels. Hydrogen atoms, which for eons only collided gently, are now slammed together with such force that they fuse. Two hydrogen nuclei merge to become helium, and in that act, a tiny fraction of their mass is converted into energy. A tremendous burst of light and heat erupts from the core. The cloud's central region stabilizes, its inward collapse halted by the furious outward pressure of this new energy. A star is born. One by one, throughout the cosmos, more of these first stars ignite. Each new star is like a lantern being lit in a vast, dark hall. First one, then another, then hundreds, then thousands. These first stars are enormous, many dozens, or even hundreds of times the mass of our sun. They burn their fuel quickly and brilliantly, shining with a hot blue-white light. Their ultraviolet radiance pours into the surrounding space, burning away and ionizing the hydrogen gas around them, carving out cavities of light in the cosmic dark. As they burst into radiance, the cosmic dawn arrives. In a poetic sense, it is as if the universe itself has declared, "Let there be light." The darkness that had prevailed since the fading of the first afterglow is banished by these newborn stars. For the first time since the universe's beginning, there are points of starlight piercing the dark, the first true stars marking the universe's morning. Picture the scene. An expanse of almost infinite night, now sprinkled with the faint glimmers of the earliest stars. They are not uniformly spread. They cluster in knots and groups, the first protogalaxies, tiny islands of light in a black cosmic sea. The universe is still young, only a few 100 million years old. And in this youth, it experiences a transformation from darkness to light. It is a gentle dawn on the grandest of scales. The light from these primordial stars is nowhere near as all-encompassing as the earlier glow of the Big Bang's afterglow. Instead, it comes from points scattered across unimaginable distances. But to the surrounding darkness, even a single star is a marvel. And here there are thousands upon thousands of them, igniting across the cosmos. The first starlight illuminates the universe's diffuse gas. Intense ultraviolet rays from these hot stars begin to heat and ionize the hydrogen in their vicinity, transforming the gas around them back into an ionized state. Bubbles of ionized, transparent space form around each star, growing outward as the star's light reaches farther into the dark. Bit by bit, these stars are clearing out the remaining pockets of cosmic fog. The cosmos is no longer a silent, uniform expanse. It has structure, and it has light. The long cosmic night has ended. A new chapter in the story of existence has begun. Yet at this dawn, there are no eyes to see it. No beings exist to witness the newly kindled stars. That will come eons later. For now, the first morning of starlight unfolds unwatched. Still, we, billions of years later, can envision it. A silent majesty of light blooming in the cosmic dark. The universe's very first sunrise. This cosmic dawn is both beautiful and brief. These first stars live fast and die young. Their lifespans measured in mere millions of years. They burn through their fuel with ferocious intensity. Yet, in the light of those short lives, they change the universe forever. The phrase cosmic dawn is fitting. The universe's long night is over, and in the new light lies the promise of everything yet to come. For in the hearts of those brilliant early suns, in the fury of their nuclear fires, something fundamental is happening. The universe is about to be enriched by the alchemy of the stars. High in the cores of those first brilliant stars, the transmutation of elements is underway. The same fusion fire that brought light to the cosmos is now forging new atomic substances, one by one. At first, deep in these stellar cores, hydrogen fuses into helium, the simplest gas transforming into a heavier one. And this fusion releases the radiant energy that makes the star shine. The star's core becomes a cauldron, tens of millions of degrees hot, and helium ash begins to accumulate from the hydrogen burning. But the process does not stop with helium. As the star exhausts its hydrogen fuel and ages, gravity presses inward again, raising the core temperature further. In the most massive of these early stars, the helium itself ignites, fusing into carbon and oxygen. When helium runs low, carbon can fuse into neon and magnesium. As the core contracts and heats each time a fuel is used up, ever heavier elements begin to form in layered shells. Oxygen fuses into silicon and sulfur, and finally, in the last days of a giant star's life, silicon fuses into iron. In this way, the massive star's interior builds up like the layers of an onion. Outermost shells still burn hydrogen into helium. Deeper shells burn helium into carbon and oxygen. Further in, carbon burns into neon and magnesium, then oxygen, then silicon. At the innermost heart of the star, a core of iron begins to form, and iron is a poison to the process of fusion. Iron, the very metal that will one day run in the blood of living creatures, cannot release energy through fusion. Fusing iron gobbles up energy instead of releasing it, and so, as iron accumulates in the core, the star's mighty furnace reaches its end. For millions of years, a delicate balance has existed. The outward pressure from intense fusion reactions has held up the star's enormous weight against gravity. But when fusion can no longer proceed, that outward push falters. The balance tips. Gravity, which has been pressing inward relentlessly all along, suddenly has no opposition. In the blink of an eye, the core of the star collapses under its own immense weight. In a fraction of a second, the iron core, which may be the size of Earth, crumples to something perhaps only a dozen miles across. The temperature spikes to incredible levels, hotter than anything since the birth of the universe, and the core's atoms are crushed together. Protons and electrons merge into neutrons, and the core becomes a stiff ball of densely packed neutrons. It cannot collapse further. It's as if the core hits a floor. The infalling material rebounds off this unimaginably hard core, and a shockwave is driven outward. The star that once shone steadily now tears itself apart in one final, magnificent blast. The outer layers are hurled violently into space. The star becomes a supernova, one of the most fearsome and spectacular events in nature. For a brief moment, this dying star outshines entire galaxies. Across light years, The darkness of space is pierced by a sudden bloom of stellar fire, a flash so bright that, if there were observers, it would outdazzle all the other stars in its galaxy. In that explosive instant, extraordinary things happen. The shockwave roaring through the star's layers triggers nuclear reactions that were impossible in the star's gentler years. In the searing crucible of the supernova, new heavy elements are forged in mere seconds. Gold, silver, platinum, iodine, uranium, elements heavier than iron, which the star could not produce during its life, are suddenly formed in abundance by the extreme energy of the explosion. Simultaneously, the imploded core at the center of the chaos is left in a bizarre state. If the original star was massive enough, that crushed neutron core remains as a neutron star, a sphere of tightly packed neutrons no larger than a city, with gravity so intense that a teaspoon of its material would weigh billions of tons. If the star was even more colossal, the core might collapse further still, vanishing into a black hole, an object of such density that not even light can escape its grasp. These exotic remnants are like silent gravestones, marking where a star's heart once was, hidden in the brilliant aftermath of the explosion. Meanwhile, the star's outer layers, now a glowing cloud of debris enriched with all those new elements, billow outward into space. All across the young universe, this drama plays out again and again. Many of those first giant stars live brief, spectacular lives and die in supernova blasts, each contributing its unique alchemy to the cosmos. The remains of these stars, titanic expanding nebulae of ejected gas and dust, spread out and drift through space, mixing with the pristine hydrogen around them. They are the gorgeous, ghostly aftermaths of the first stars, and within their colourful clouds lie the seeds of everything that will come later. Carbon that will one day form the backbone of organic life, oxygen that will fill the lungs of future creatures and the skies of future worlds, silicon that will make rocks and sand on distant planets, and iron that will course in the blood of beings yet unborn. Tiny grains of solid matter condense out of the cooling gases, literal stardust, small solid flecks containing minerals and metals floating through the galaxy as souvenirs of these stellar deaths. In the wake of the first supernovae, the universe is no longer the simple place it was at birth. The initial purity of hydrogen and helium has been irrevocably changed by the introduction of heavier elements. Every supernova is like a cosmic flower blooming and then casting its seeds to the cosmic winds. Those seeds, the stardust and heavy elements, drift into giant gas clouds, enriching them with new possibilities. And in time, gravity will cause those enriched clouds to coalesce and form new stars, just as it did before. But now, when new stars are born, they will carry with them a treasure of heavier elements in their midst, ingredients for planets, oceans, and life. Think of a massive star's death as a kind of celestial recycling. Nothing is wasted in the universe. Destruction leads to new creation. The end of one star becomes the beginning of many others. The violent shock of a supernova can jostle nearby gas clouds, triggering them to collapse and form fresh stars, like cosmic seeds sprouting after a forest fire. Indeed, after the first generation of stars, a second generation begins to shine. Stars born from the blended remains of their ancestors. These new stars are a bit different. They can be smaller, live longer, and burn more gently. In fact, for stars only a few times more massive than our Sun, or smaller, The final fate is not a cataclysmic explosion, but a peaceful shedding of their outer layers. Such a star, as it grows old, will swell into a red giant, and then, as its outer layers drift away, form a beautiful glowing shell called a planetary nebula, a colourful bubble of gas expanding into space like a delicate cosmic butterfly. The core of the star remains behind as a white dwarf, a hot, dense ember roughly the size of Earth, which will slowly cool over billions of years. This gentler process, too, returns elements to space. The red giant winds and planetary nebula carry carbon, nitrogen, and other elements into the galaxy's reservoirs. Whether through the quiet sigh of a dying medium-sized star or the deafening blast of a supernova, the result is the same. The cosmos grows richer in elements with each generation of stars. Over hundreds of millions and then billions of years, this stellar cycle continues tirelessly. Star birth, star death, star rebirth, each generation adding more metals, as astronomers call these heavier elements, to the cosmic brew. The vast spaces between stars, once filled only with hydrogen and helium, become seeded with carbon, oxygen, iron, and all the ingredients of planets and life. From a near-sterile beginning, the universe gradually becomes a chemical garden. The fires of countless stars have cooked up a cosmos that is ever more complex. The universe is evolving not just in form, but in substance. If we pause to reflect, this process has an intimate connection to us. It may seem that these titanic events, stars exploding or gently puffing away their layers, are far removed from our quiet existence on a small, lush world. But in fact, they are our direct ancestors. Every atom in your body has gone through this cycle of cosmic creation and dispersal. The calcium in your bones, the iron in your blood, the carbon in every living cell, all were forged in the heart of a star that lived and died long before the Earth came to be. Eons ago, in some ancient stellar furnace, atoms of iron were crafted and then cast into space by a supernova's fury. For ages, those atoms drifted, mingling in an interstellar cloud, until that cloud collapsed to form new stars and planets. On one of those planets, our Earth, those atoms became part of the rocks, the oceans, and eventually part of living beings. In a very literal sense, we are made of stardust, the dust of ancient stars now given new life in us. Imagine for a moment a single atom of iron within your body, perhaps in a red blood cell carrying oxygen through your veins. That atom's journey began billions of years ago in the core of a star. It was forged in stellar fire, then flung into space when that star died in a brilliant supernova. It drifted in the great darkness, part of a spreading cloud of gas. Eventually, that atom found itself drawn into a new star system, forming out of that cloud. It became part of the young Earth, locked in rock for eons, until geological processes freed it. Perhaps it dissolved into seawater, then was absorbed by a primitive organism, cycling through food chains, and finally became part of you, in the food you ate or the water you drank. Now that ancient atom journeys through your bloodstream, a tiny link between you and the cosmos at large. And when, far in the future, your life's journey ends, that atom will return to the Earth, and perhaps someday, far ahead, it may become part of another living thing or another world. Multiply that story by trillions upon trillions, and you begin to sense the depth of connection between ourselves and the stars. So, as the early universe undergoes its stellar alchemy, it is not just crafting elements. It is ultimately crafting the ingredients of life and consciousness to come. In the ashes of dead stars lie the raw materials for everything that will follow. New suns with their orbiting planets, some of which will have landscapes and seas, and perhaps life that gazes up at the heavens. The cosmos is becoming self-aware in slow motion, preparing the way for eyes that will see and minds that will wonder. But before those eyes and minds exist, the universe must organize itself on a grander scale. Even as individual stars live and die and share their riches, those stars are gathering into immense communities. The stage of the cosmos is about to widen, from solitary stars to vast cities of stars called galaxies. Stars do not remain solitary for long. Under the guidance of gravity, they congregate by the millions and billions, assembling into enormous structures that span tens of thousands of light years. The same tiny fluctuations that drew gas into the first stars now pull stars toward one another, along with the gas and dust that remain. Over time, these stellar gatherings grow into the first proto-galaxies, the seeds of future grand galaxies. Picture a stellar city taking shape, countless suns moving in a gravitational dance, bound together by their collective pull. As more stars form and more material flows in, the structures grow larger and more organized. The early universe, once nearly uniform, develops a cosmic architecture as star clusters merge and coalesce into great islands of light. These nascent galaxies come in many shapes and sizes. Some are diffuse and irregular, little more than ragged clusters of stars. Others begin to spin, flattening into disc-like forms, hinting at the graceful spirals they might become. Within them, new generations of stars spark into being, adding their illumination to the growing galactic glow. Massive stars live and die within these systems, and their remnants mix with gas to enrich it, spurring yet more star formation. It's a self-perpetuating cycle. Over billions of years, small protogalaxies collide and merge, and galaxies transform. A modest collection of a few million stars can, through successive unions and accretion of more matter, become a majestic galaxy of 100 billion stars. Gravity is the master architect of this grand assembly. And not only the gravity of the things we can see, the stars and gas, but also the pull of something we cannot see, an enormous hidden scaffolding that underlies the visible universe. Scientists call it dark matter, a mysterious form of matter that neither emits nor absorbs light. It outweighs the ordinary matter by a factor of about 5 to 1 and forms a kind of invisible framework for galaxies. Galaxies take shape where great halos of dark matter have drawn regular matter into their gravitational wells. In these cradles, stars and gas collect and swirl. We can't see the dark matter directly, but we infer its presence from the way galaxies rotate and cluster. It's as if each galaxy sits in a transparent halo of gravity, a heavy, unseen hand guiding the formation and holding it together. As the universe ages into the billions of years, it becomes a tapestry of galaxies. They are scattered across space in groups and clusters, connected by filaments like the threads of a cosmic web. On the largest scales, galaxies trace out a pattern that resembles foam or lace. Filaments and walls of galaxies surrounding immense voids where few galaxies reside. Clusters of galaxies form at the intersections of these filaments, immense cities of galaxies bound together by gravity, containing hundreds or thousands of individual galaxies swarming about each other. Between these clusters stretch great dark spaces, cosmic oceans where only the occasional galaxy drifts. Seen from far, far away, the distribution of galaxies might look like the structure of a sponge or the neural patterns of a brain, intricate and beautiful, an almost organic pattern on the grandest scale. Within a single galaxy, the dance of stars continues on and on. Many galaxies spin gracefully, like colossal whirlpools of starlight. In a typical spiral galaxy, bright arms sweep outward from a glowing central core, each arm speckled with the blue light of hot young stars and the pinkish clouds of nebula, the birthplaces of stars. These spiral arms are not solid structures, but density waves, like traffic jams of stars and gas that move around the galaxy, triggering star formation as they go. Under the soft shine of billions of stars, dark ribbons of interstellar dust trace the spiral patterns too, marking where new stars may soon ignite. The core of a spiral galaxy often shines golden, with older, cooler stars crowded together. And in that core lurks one of the most mysterious objects in the cosmos. A supermassive black hole, millions or even billions of times the mass of our sun. Long ago, in the galaxy's youth, gas, and perhaps whole stars, fell into this central black hole, causing it to blaze as a quasar, a phenomenon where the core of a galaxy outshines everything else due to material plunging into a black hole. Now, in a mature galaxy, the central black hole is usually quiet, a sleeping giant that announces its presence only by the fast orbits of stars around it. It sits as a heavy, unseen anchor at the galaxy's heart. Not all galaxies have the elegant spiral structure. Some are elliptical galaxies, gigantic ellipsoids of stars that might look like a hazy football or a glowing sphere. These galaxies often contain older stars and little gas, meaning they have few new stars being born. Astronomers believe many ellipticals form from the collisions and mergers of smaller galaxies. When two galaxies collide, an event that unfolds over many millions of years, their stars pass by each other like grains of sand in colliding clouds, mostly not hitting directly because of the vast distances between stars. But the gravitational interactions are complex. The galaxy's shapes distort. Long tidal tails of stars can be flung out. Gas clouds can crash and spark new star formation. Eventually, the two galaxies may settle into one larger, more rounded collection of stars. Spiral patterns get scrambled. The result might be a big elliptical galaxy with stars on more random orbits. There are also countless dwarf galaxies, small and faint, often chaotic in shape. These tiny galaxies swarm around bigger ones and sometimes get torn apart, their stars assimilated by their larger neighbours. Galactic encounters are majestic and slow-motion dances. When galaxies draw near each other, their mutual gravity can pull out extravagant tidal streams of stars and gas, bridging the galaxies or wrapping around them. Over time, if they merge, the new galaxy that results may be temporarily ragged and fiery with starbirth before settling into a stable form. Even now, our own Milky Way bears the marks of past mergers, streams of stars in our galaxy's halo that once belonged to smaller galaxies devoured long ago. And in the far future, our Milky Way will collide and merge with the Andromeda galaxy, our nearest large neighbour. In about 4 billion years, the two spirals will start to intertwine, eventually forming a single, larger galaxy, perhaps a giant elliptical. Such events remind us that the galactic tapestry is still being woven. It is dynamic, not static. Amid this grand design, each galaxy is a universe unto itself, containing myriad stars and likely uncountable planets. They are like islands in the vast ocean of space, each island glowing with the light of its stars. Some galaxies may have trillions of stars, others only a few million, and the number of galaxies is truly staggering. The observable universe contains hundreds of billions of them. It's a number that drifts into the unimaginable. If each galaxy were a single grain of sand, the beaches of an entire world would not be enough to hold them all. It is humbling and awe-inspiring. On the scale of the universe, even a galaxy, enormous as it is but a point in a grand pattern. One of these countless galaxies is destined to be very special to us, not because of its size or brightness, but because within it lies our home. It is a spiral galaxy of average stature, one among the billions, with gracefully curved arms and perhaps a barred shape in its centre. This is the Milky Way, our galaxy. It formed relatively soon after the Big Bang. Some of its stars are nearly as old as the universe. And it grew by accreting gas and merging with smaller proto-galaxies over billions of years. By around 9 billion years after the Big Bang, the Milky Way had matured into a magnificent spiral, rotating once every few 100 million years. Its spiral arms, adorned with star clusters and nebulae, wind out from a central bulge. Our galaxy is part of a small cluster of galaxies known as the local group, gently bound by gravity. And together with tens of thousands of other galaxies, it's part of the Virgo supercluster, one thread in the cosmic web. Even from afar, the sight of a galaxy like the Milky Way would be breathtaking. If one could float in the intergalactic darkness and behold it, the Milky Way would appear as a luminous disk, a pale, glowing pinwheel suspended in space. The central region would shine like a compact lantern of golden light, the combined glow of millions of old stars crammed together. Spiral arms would emanate from this centre, tinted bluish by young stars and speckled with pinkish blotches of light from hydrogen clouds excited by newborn stars. If you looked edge-on at the Milky Way, you'd see a slender band of light crossed by dark streaks of dust, that same band we observe from inside as the milky ribbon across our night sky. To grasp its scale, remember that the Milky Way spans about 100,000 light-years from end to end. A beam of light, racing at 300,000 kilometers per second, would take 100 millennia to go from one edge of our galaxy to the other. And within that vast disk, hundreds of billions of stars orbit the galactic center, each star taking tens or hundreds of millions of years to complete a single circuit. Our Sun, once it exists, will require roughly 200 million years to travel once around the galaxy. Even galaxies themselves, with all their stars, move on a grand stage. In clusters, they orbit each other, and our local group galaxies, the Milky Way and Andromeda included, are falling toward each other for their future embrace. Now, in a quiet corner of this galaxy, on a spiral arm known as the Orion Arm, a minor spur of stars and gas between two larger arms, there is a vast cloud of gas and dust. It has been there for ages, cold and dark, a repository of the materials forged in countless earlier stars. This cloud is rich in hydrogen and also seeded with carbon, oxygen, silicon, iron, all the heavy elements made over the preceding billions of years of stellar cycles. It's an enormous molecular cloud, tens of light years across, and within it lie denser clumps, like cores within a great womb of gas. Gravity, ever patient, has been nudging and squeezing this cloud. Perhaps a shockwave from a distant supernova has rippled through it, or the tidal forces from the Milky Way's rotating disk have agitated it. Whatever the cause, parts of the cloud begin to collapse inward. One such region, destined to be very important to us, starts to draw in material and grow denser. This is the beginning of our solar system. In this dark, quiet corner of the Milky Way, a gentle hush presides as a great, invisible drama unfolds. A clump within the cloud collapses, and as it does, it starts to spin. The conservation of angular momentum, the tendency of a rotating object to spin faster as it shrinks, causes the collapsing clump to whirl more and more quickly, like a skater pulling in their arms. The collapsing gas flattens into a disk around a central point. At the center, matter is piling up, growing denser and hotter by the day, or what would be days, if days existed yet. This is the birth chamber of a star, our star. Deep within that collapsing fragment of cloud, the pressure and temperature climb relentlessly. What was once just a cold, diffuse patch of gas has become a glowing, dense protostar hidden inside a spinning cocoon of dust. For countless years, this infant protostar continues to gather mass from the infalling cloud. The surrounding disk, like a cosmic carousel, whirls around it, full of gas and dust and the building blocks of future worlds. At the protostar's core, the temperature is still rising. When it surpasses a few million degrees, the first whispers of fusion begin. But the star isn't fully ignited yet. The protostar is like a hot ember, not visible in traditional light, but glowing in infrared. Eventually, after roughly 50 million years of contraction and heating, a critical threshold is reached. The core temperature hits about 10 million degrees. At this point, hydrogen nuclei, protons, are moving fast enough to overcome their mutual repulsion and slam into each other, fusing into helium. In that moment, a new kind of light and energy floods outward from the core. The protostar stabilizes. Nuclear fusion is now generating enough outward pressure to balance gravity. A star is born. Our sun has ignited. It is not yet as bright as it will be in its middle age, but already it shines with a steady brilliance. The newborn sun's light and heat push back the remaining gloom of the collapsing cloud. A strong wind of particles, the young sun's stellar wind, begins to blow, and the intense radiation pressure from the sun clears away much of the leftover gas and dust, especially from the inner part of the surrounding disk. The opaque shroud that hid the forming star is blasted away into space. Sunlight, golden and new, streams out in all directions, illuminating the vicinity and announcing the sun's presence to the galaxy. And the sun is likely not born alone. Nearby, dozens of sibling stars are also coming to life from the same vast cloud. Our sun's birth is part of a stellar cluster, a crowded nursery of young stars, that briefly shine together in this region of the Milky Way. In time, these stellar siblings will drift apart, scattering across the galaxy. But for a while, they are a family of bright newborn suns, sharing the neighborhood. Meanwhile, in the disk around the sun, countless particles of dust and ice are orbiting, colliding, and merging. This protoplanetary disk is the construction site of planets. At first, grains of dust stick together by electrostatic attraction, forming fluffy clumps that grow into pebbles. The pebbles collide gently and merge into rocks. Over thousands and then millions of years, rocks gather into boulders, and boulders into mountain-sized bodies called planetesimals. The solar system is a chaotic place during this time, countless objects whirling around, some merging to build larger bodies, others shattering in violent collisions. Gradually, however, the debris begins to sort itself out. The biggest bodies grow larger, sweeping up smaller ones, their gravity helping them dominate their orbits. In the region close to the Sun, conditions are harsh. The Sun's heat is intense, and lighter materials like ices and gases cannot easily condense. In these inner orbits, only metals and rocky minerals can solidify, so the planetesimals there are made of iron, nickel, silicates, heavy, sturdy stuff. These will form the terrestrial planets. Farther out, beyond a certain distance, often called the frost line, the Sun's warmth is weak enough that volatile compounds like water, methane, and ammonia can exist as ice. In these outer orbits, the planetesimals can incorporate not just rock and metal, but lots of ice. They grow much larger, and because of their stronger gravity and the abundance of material, they begin to capture and hold on to the surrounding hydrogen and helium gas as well. These will become the giant planets. After a few million more years, the solar system has taken shape. There are 8 primary planets orbiting the Sun, along with a multitude of smaller bodies. Closest to the Sun is Mercury, a small, broiling world of iron and rock. Its surface is cratered and baked, having formed in the oven of the Sun's glare. Next comes Venus, nearly the same size as Earth, wrapped in a dense veil of clouds. Venus's surface will become infernally hot under a thick blanket of carbon dioxide, but for now it's a cooling globe of lava fields. Then, at a comfortably moderate orbit, a world of great importance emerges. Earth. At this early stage, Earth is a molten sphere glowing with the heat of its formation, its surface an ocean of magma. A constant rain of asteroids and comets bombards it, contributing to its heat and mass. Further out, the 4th planet Mars coalesces. Mars is smaller than Earth and cooler. It's destined to become a cold, rusty desert. Early on, Mars may have lakes and rivers under a protective sky, but it is too small to hang on to this bounty. Before long, much of its air will escape, and its water will freeze or dissipate, leaving Mars a dry, barren world, a desert in the making. These are the inner planets, 4 small, dense, rocky bodies that will have solid surfaces and, at most, thin atmospheres. Beyond them, an entirely different kind of planet forms. The 5th planet out is Jupiter, which has quickly become a giant. Jupiter is by far the most massive of the new worlds, a colossal sphere mostly of hydrogen and helium gas, a miniature star in composition, though not in size. It lacks a solid surface, and instead has an ever-thickening atmosphere, leading to perhaps a liquid or metallic hydrogen interior under crushing pressures. Jupiter's appearance is banded and stormy, with clouds of ammonia crystals and other compounds forming stripes. In these clouds, a gigantic storm system swirls. The Great Red Spot, a storm so large that 2 Earths could fit within it. This raging hurricane may have already formed and could persist for centuries or millennia. Jupiter's gravity dominates its region of space, gobbling up a huge share of the material. In fact, Jupiter's presence likely prevents any significant planet from forming at certain distances around it. Between Jupiter and Mars, the leftover debris remains as countless pieces, the asteroid belt, rather than coalescing into another Earth-sized planet. Next comes the resplendent Saturn. Slightly smaller than Jupiter, but still enormous, Saturn forms from similar gases and ices. It develops a stunning feature that will later captivate skywatchers, a broad, flat system of rings encircling the planet. These rings are composed of countless pieces of ice and rock, each orbiting like a tiny moon. They might have formed from the remnants of a moon or comets that were torn apart by Saturn's gravity, or from primordial material that never coalesced into a moon. Saturn's golden atmosphere is serene in appearance, banded like Jupiter's, but more subtly so. Farther out, in the deep freeze of the outer solar system, 2 ice giants emerge, Uranus and Neptune. These planets are smaller than Jupiter and Saturn, but still many times the mass of Earth. They have solid cores of rock and metal, wrapped in thick mantles of ices, water, methane, ammonia, and outer layers of hydrogen and helium. Uranus and Neptune appear blue-green. The tint comes from methane gas in their upper atmospheres, which absorbs red light. Uranus ends up with a peculiar orientation. It orbits the Sun, tipped over on its side, like a rolling ball. This strange tilt is likely the result of a titanic collision during its formation, a massive impact that knocked Uranus askew. Because of this, Uranus's rotation axis points almost toward the Sun, and it essentially rolls along its orbit. Neptune, even farther from the Sun, becomes a dynamic world with the fastest winds in the solar system, supersonic gales that whip through its frigid atmosphere. Although receiving only a trickle of sunlight, Neptune's internal heat drives these wild winds, and dark storm spots appear on its face from time to time, testament to activity in the dim reaches of the Sun's influence. All around and between these planets, a plethora of smaller bodies fill the solar system. Between Mars and Jupiter swarms the asteroid belt, rocky and metallic leftovers, some as small as pebbles, others hundreds of kilometers across. They are remnants of the building process, either pieces of a planet that never formed, or shards from collisions that shattered planetesimals during formation. Far beyond Neptune, a region called the Kuiper Belt hosts countless icy objects, remnants of the primordial disk that survived in the outer cold. Pluto is one of these, a tiny, icy world among many. And stretching even farther, like a vast sphere surrounding the solar system, is the Oort cloud, a repository of comets. These icy wanderers are like dormant seeds at the edge of the Sun's domain. On occasion, a disturbance, perhaps a passing star, or the tidal forces of the Milky Way, will nudge one of these icy bodies from its distant orbit and send it spiraling inward toward the Sun. As it approaches the inner solar system, it comes alive. The Sun's heat causes the comet's ices to vaporize and stream out into space, forming a luminous tail that can stretch for millions of kilometers. These comets will grace the skies of the young planets with glowing tails of dust and vapor. Some of them may even collide with the planets, delivering water and organic molecules to their surfaces and seeding the ingredients for life. In the early epoch of the solar system, such cometry and asteroidal bombardment is frequent and intense. Our newborn sun now settles into stable burning, shining brighter and more steadily with each passing eon. The chaotic disk of dust and gas that once surrounded it has mostly been cleared away, incorporated into planets, swept into the sun, or blown out of the solar system by the solar wind and radiation. What remains are the planets, large and small, moving in well-defined orbits, and the belts of leftover debris. Yet the solar system's youth is anything but calm. The newly formed planets continue to experience frequent impacts from the residual clutter. There are still thousands of asteroids and comets on unstable paths. The inner planets, in particular, endure a heavy late bombardment, waves of impacts that heat and scar their surfaces. Meteors streak through the skies incessantly. Giant asteroids occasionally strike, releasing energy equivalent to billions of atomic bombs, melting crusts, and boiling oceans. It's a dangerous time, but also a time that brings crucial ingredients to the young worlds. On the young Earth, this bombardment contributes both destruction and delivery. Each major impact melts part of Earth's surface anew, creating seas of lava and resetting any progress towards a solid crust. At the same time, many of the impacting objects, especially comets and certain asteroids, carry water in the form of ice, as well as carbon-based molecules. They deposit some of this water and organic material upon impact. Earth's gravity and its developing atmosphere manage to retain a portion of this water. So, even as Earth is pummeled, it is also being watered. At first, Earth is a hellscape. The surface is an incandescent ocean of magma. With each large impact, rock vapor and dust are thrown into the nascent sky. The air is a thick, toxic fume of carbon dioxide, sulfur dioxide, nitrogen, and water vapor, laced with the glow of molten rock raining back down. The young planet's internal differentiation has begun. Heavy elements like iron and nickel sink inward to form Earth's core, while lighter silicates rise toward the surface to become the mantle and crust. This separation releases gravitational energy and heats the Earth further. Volcanoes are erupting everywhere, bleeding heat and gases from the interior. Not long, in cosmic terms, after Earth's formation, a final cataclysmic event occurs that will forever shape the Earth's destiny. A wandering protoplanet, sometimes called Theia, roughly the size of Mars, is on an intersecting trajectory with Earth. In a titanic, glancing blow, this body collides with the Earth. The impact is immense, beyond comprehension. It momentarily vaporizes a significant portion of Earth's crust and mantle, mixing the material of the two colliding worlds. Earth is left molten again, its spin dramatically sped up. A huge amount of debris, molten rock and metallic droplets, is ejected into orbit around Earth. Within weeks or months, that debris, pulled by its own gravity, coalesces into a new body orbiting the Earth. This is how the Moon is born. At first, the Moon is a blazing ball of lava. Just as Earth is once more, it orbits very close to Earth, perhaps only 20 or 30,000 kilometers away, a tiny fraction of its current distance. It would have filled a huge portion of the sky, appearing dozens of times larger in diameter than it does to us now. Tidal forces between Earth and this proximity moon are enormous. The newly formed moon raises gargantuan tides on Earth, not only in any nascent oceans, but even in the semi-molten rock of Earth's surface, causing tidal waves of lava hundreds of meters high to rise and fall. Likewise, Earth raises tides on the still molten moon, heating and shaping it. The collision and its aftermath leave Earth spinning rapidly. A day on the young Earth might have been a mere 5 or 6 hours long after that impact. At the same time, the moon's close presence begins to exert a braking effect on Earth's rotation. With each passing century, the friction of tides raised by the moon in Earth's oceans, once they exist, and crust steals a bit of Earth's rotational energy and transfers it to the moon's orbit, causing Earth's spin to slow and the moon to recede. Over billions of years, this will continue until Earth's day lengthens to the familiar 24 hours and the moon circles much farther away. The moon's steady gravitational tug will also act as a stabilizer on Earth's axis, preventing it from wobbling chaotically. Thanks to the moon, Earth will have relatively gentle and regular seasons rather than extreme swings, a crucial factor for long-term climate stability. But all that is far in the future. Right now, in the aftermath of the giant impact, both Earth and moon are molten and glowing, and Earth is recovering from yet another global cataclysm. Gradually, Earth cools again from this fiery state. Much of the debris thrown into orbit falls back to Earth as incandescent rain, adding heat but also eventually building up parts of the crust. Over tens of millions of years, the Earth's surface solidifies into a new crust of rock. The heavy bombardment from the leftover planetesimals continues, but the intervals between big impacts grow longer. The most violent era passes as the solar system clears out its excess debris. One by one, the remaining big impactors either collide with planets or are flung out of the system or settle into stable orbits like the asteroid belt. The late heavy bombardment, as it's often called, leaves its marks. The moon's once molten surface solidifies and is peppered with innumerable craters from this time, and those craters remain visible billions of years later, since the moon has no weather or oceans to erase them. Earth surely bore just as many scars, but our planet's active geology and erosion will gradually obscure or recycle them. Even now, the moon's myriad craters bear witness to that intense era, a record of the ancient bombardment etched in its silent, airless face, while on Earth hardly any craters survive from those times. As the barrage wanes, Earth begins to attain a kind of equilibrium. The planet, which started as a glowing ball of magma, now has a solid crust in many places. Volcanoes still erupt frequently, building the first small islands and mountain ranges. Gases pour from these volcanoes, forming a thick atmosphere around the Earth. This primordial atmosphere is very different from what we breathe now. It is rich in carbon dioxide, with substantial nitrogen and water vapor, and likely traces of methane and ammonia. There is little to no free oxygen. That will come much later, as a product of life. At first, the Earth's surface remains extremely hot, well above the boiling point of water. But as time passes and impacts become rarer, the surface cools. The ubiquitous volcanic eruptions also release water vapor that had been trapped in Earth's interior. As the temperature falls below about 100 degrees, this water vapor can begin to condense into liquid. Clouds form in the sky, thick, dark clouds that begin to drench the cooling Earth in rain. Imagine the first rain on Earth. After millions of years of searing heat, the rocks have finally cooled enough that water can last as liquid. The skies, which were filled with steam, now unleash torrential downpours. At first, the raindrops hiss and sizzle into vapor again upon hitting the still hot ground. But the deluge continues relentlessly. Eventually, puddles persist on cooler patches of rock. The puddles grow into ponds. Rainwater gathers in great basins on the forming crust. The ponds merge into vast lakes and then oceans. Perhaps within a few 100 million years after the moon-forming impact, Earth comes to have substantial standing water on its surface. Continual cloud cover shrouds the young sun, but occasionally a ray of sunlight breaks through to illuminate a steaming, wet landscape. Volcanic islands punctuate these early oceans, the first proto-continents. Lava flows build up new land, which hardens and rises above the water in places, only to be eroded by ceaseless rain. These rocky islands may coalesce into larger landmasses, riding on the moving plates of Earth's young crust. The surface of the planet is dynamic. Entire sections of crust, plates, slowly drift, pushed by convection in the mantle. When they collide, they crumple to form the first mountain ranges. When they pull apart, magma wells up to form new crust. By this tectonic dance, the face of Earth is ever changing. But gradually, a pattern emerges. Concentrations of lighter rocks form the kernels of continents. By the time Earth is perhaps a few 100 million years old, it likely has small continents or large islands dotting a global ocean. The sun, which in its infancy was a touch dimmer than it is now, shines down on this transformed Earth. The sky, once perpetually clogged with ash and steam, is starting to clear to a translucent blue as the water vapor condenses into oceans, and carbon dioxide begins to dissolve into water and react with rocks. The sun's rays warm the surface, and the blanket of greenhouse gases, chiefly carbon dioxide, traps enough heat to keep the oceans liquid, despite the sun's slightly weaker output in those days. Day by day, the sun grows a little stronger, for stars like the sun increase in brightness slowly over time, and Earth's greenhouse atmosphere perhaps moderates in tandem, maintaining a clement temperature for water. By now, the moon has receded to a greater distance, but it still looms much larger in the sky than it does in our era. It causes powerful tides in the new oceans, tides far higher than those we see today. These tides relentlessly stir coastal waters, mixing nutrients and creating rhythms, a clock in the sky that moves the very oceans. In the air, there is as yet no oxygen. The sky's blue colour comes from the scattering of sunlight by nitrogen and by the tiny droplets in clouds. It would likely have a more orange or reddish tinge during the day than our current sky, due to the higher CO2 content. The ocean probably has a greenish cast, loaded with dissolved iron and lacking life to clear it. Yet, all the ingredients for life are present. The water is laden with minerals and chemicals. Energy is abundant, from volcanically heated undersea vents, from lightning in the humid, stormy skies, from ultraviolet sunlight, since no ozone layer exists yet to block it. On land, rainwater trickles through minerals, perhaps forming warm little ponds that go through wet and dry cycles, concentrating organic molecules. In the depths, hot vents spew a chemical broth into the ocean, creating gradients of energy and chemistry. At this point, roughly 3.9 to 4.0 billion years ago, the stage is fully set for a new kind of phenomenon. The universe, through the long journey of cosmic evolution, has finally produced a world with a stable crust, oceans of water, a protective atmosphere, and a rich supply of chemical building blocks. From the primordial whisper in the void to the first light of stars, from the forging of elements in stellar hearts to the gathering of stars into galaxies, and from the debris of countless star deaths to a newborn star with a family of planets, the long chain of events has led to this: a young Earth under a gentle sun, waiting for life's spark. As we conclude this chapter of the cosmic story. Picture this serene scene. A warm earth turning slowly under the pale gold light of a younger sun. The heavens above, still filled with uncountable stars in a Milky Way much like today's, and a giant moon hanging in the sky, casting a silvery path on the waters. The void that was once dark and empty is now rich with light and material. And on at least one small world, liquid water laps against solid ground. The journey of creation has been a long and wondrous one, nearly 10 billion years from the birth of the universe to the emergence of our sun and planet. And yet, it is far from over. The stage is set, and the curtain is about to rise on an even more intricate act, the story of life and consciousness, through which the universe will begin to know itself. In the calm after the storm of creation, our earth holds the promise of everything to come. The sky has shifted from angry red-orange to a softer blue, and by night the first stars sparkle above a cooling world. In those stars' gentle light, one could sense a reflection of the past. They are the same lights that seeded Earth's making. It is as if the cosmos is quietly aware of its achievement. For on this small world, the ingredients for eyes to see and minds to dream have assembled. In time, living creatures will stir in the seas, and some will look up and wonder at the sun, moon, and stars, not realizing at first that it's their own story written in the sky. The universe, through those future beings, will soon be dreaming in the void, contemplating its own existence. But that is the tale of the next dawn. For now, in this precious moment of cosmic dawn, we have a newborn star warming a blue young planet and the profound hush that precedes the next great awakening. The void is no longer empty. It is full of possibility. And the ultimate adventure, the journey of life, is about to begin. Imagine drifting silently through the velvet darkness of space, carrying with you the calm awareness we have cultivated. Below, a small planet slowly turns in the sunlight. At first, it appears as a glowing ember, a young world still hot from its creation. This is Earth in its infancy. In that distant past, it wore a fiery cloak. Oceans of magma and roaring volcanoes that spewed molten rock and thick clouds into a ruddy sky. Yet even in this turbulent youth, seeds of something remarkable were being sown. As time flows on in a slow cosmic rhythm, the earth begins to cool. Its surface hardens from molten glow to solid ground. The rain starts to fall, at first in steaming torrents that hiss upon the newborn rocks. For countless years, warm rain pours from dense clouds, pooling in low basins and craters. Those first raindrops carry a promise, quenching the hot lands and gathering into the very first seas. Some of the water filling these basins may have been here from the start, trapped in minerals and released by volcanoes. Some arrived from space, delivered by countless comets and ice-bearing asteroids that bombarded the young Earth. Every icy impact was like a celestial gift, adding to the growing oceans. In a sense, the oceans themselves are partly alien. Waters from distant corners of the solar system gathered here in one cradle. Now, from the quiet of space, you observe a transformation. The planet that once glowed red with fire now shimmers with cool blues and whites. Vast young oceans spread out, covering much of the surface in a sparkling expanse. They reflect the sunlight back into space, giving Earth a delicate azure halo. Swirls of white cloud drift above blue seas and dark, nascent continents, moderating the sun's heat with their shade and carrying fresh rains to the ground below. The Earth takes on a serene face. Seen from afar, it is a lonely blue marble suspended in the void, glowing softly against the black cosmic canvas. This gentle blue glow marks the dawn of a unique world, a world that will nurture life. In this early era, the sun's light bathes Earth with a steady warmth. Day and night already trade places in a reliable dance as the planet spins, though no eyes are yet open to see the sunrise or sunset. In a particularly dramatic chapter of this epoch, a wandering protoplanet collides with the young Earth, shearing off a portion of Earth's molten body. The debris from this cataclysm gathers into a glowing ring around the Earth, and from that ring the moon is born. At first, the newborn moon hangs much closer and shines fiercer, a molten orb in the sky. Over time, it cools and drifts farther out, settling into orbit as Earth's constant companion. Each night, this nascent moon lofts above the horizon, its gravity quietly tugging on the new oceans, drawing tides that whisper across untouched shores. These rhythmic tides become a lullaby to a world in waiting. Below the water's surface, minerals and chemicals mingle, stirred by currents and warmed by undersea volcanoes. Lightning forks down from stormy skies, and meteorites occasionally streak through the air, delivering exotic ingredients to the oceans. All these influences mix in the warm primordial sea, a rich broth of possibility. The young Earth's gentle environment, with its water and warmth, cradles these ingredients with patience. There is no rush in this world. Time stretches out over millions upon millions of years. During daylight, ultraviolet rays from the sun beat down on the water's surface, driving chemical reactions, while at night the planet radiates heat back into space, letting cooling molecules recombine in new ways. In the deep sea, hydrothermal vents gush mineral-rich hot water, creating pockets of warmth and energy on the ocean floor. Within warm, tidal pools along rocky coasts, waves repeatedly concentrate and then dilute organic compounds, perhaps helping complex structures to form. In the stillness between storms, something quietly profound is about to take shape. For now, Earth remains a world of simple geologies and weather. Dawn breaks on steaming seas and barren rock coasts. At night, under alien stars, the surface rests in darkness, with only the sigh of wind over water and the distant rumble of volcanism. Yet even in these dark nights and quiet moments, the stage is being set. Every cooling rock, every droplet of water, every beam of sunlight filtering through the clouds is part of a delicate balance coming together. Our planet has calmed from its violent birth, and in calming, it has become hospitable, a gentle cradle awaiting a miracle. You might imagine drifting just above those early waves on a clear day. The water stretches to the horizon, a vast and empty ocean beneath a pale sky. The air is thick with carbon dioxide and nitrogen. It would smell acrid to us, but it nurtures the ocean's chemistry. There is no scent of life yet, no whisper of leaves or chorus of animals, only the sigh of wind and the lap of water. If you listen closely in your mind, You might fancy the faint bubbling of gases rising from vents in the seabed. This is Earth long before any living thing drew breath. It won't remain lifeless for long. In the great expanse of time, a few 100 million years pass, almost unnoticed. Slowly, subtly, the chemistry in the oceans grows more complex. By chance, or perhaps inevitability, certain molecules begin to join into self-replicating structures. Some form delicate membranes, little boundaries that separate an inside from an outside. Others begin to harness energy from chemical reactions or sunlight. At some point, a threshold is crossed. The first glimmer of life flickers in the water. It might be nothing more than a microscopic sphere, a protocell floating in the nutrient-rich sea that can absorb molecules from its surroundings and grow. Maybe even divide to make a copy of itself. It is fragile and simple, yet it holds astounding potential. The miracle in the cradle has arrived quietly. In the beginning, life is exceedingly humble. These first living cells drift in the ocean's depths and shallows, invisible to any eye. They feed on chemical energy and the day's faint sunlight, multiplying slowly. Many cluster around warm vents on the ocean floor, where mineral-laden water gushes from Earth's interior. In these dark, warm oases, microbes find food and shelter. Others ride the currents near the surface, absorbing sunshine as nourishment. For millions upon millions of years, such simple cells are the only inhabitants of Earth, an unseen yet vital presence spread through the sea. From our distant vantage, nothing on the surface betrays the momentous change that has occurred underwater. Yet if we could descend into a droplet of that ancient ocean, we would find it teeming with a microscopic garden. Among the tiny pioneers is a special kind of microbe that learns a transformative trick. It captures sunlight and uses that energy to turn carbon dioxide and water into food. In doing so, it releases a byproduct, a gas called oxygen. At first, the oxygen is absorbed by ocean waters and reacts with rocks, but eventually it begins to flood the atmosphere. In time, the sky itself changes colour. What was once a hazy dome of volcanic gases becomes a clearer blue sky, thanks to the oxygen exhaled by countless swarms of these microbes, our planet's first cyanobacteria. Under this new sky, the Earth truly becomes the blue planet, with seas of sapphire below and daylight heavens of cerulean above. This oxygen is both a gift and a challenge. It is toxic to many of the earlier microbes that had lived without it. A great crisis unfolds in the primordial seas as some life forms perish or retreat into oxygen-free muds and deep sediments. But other microbes adapt and thrive in the new air, finding oxygen tremendously useful for energy. The Great Oxidation, as it will be called, cleanses the world in a way, removing old life that cannot cope, but providing opportunity for new life that can. In the wake of this change, life diversifies. The sky's new hue is a harbinger of both death and renewal, a reminder that even at this microscopic scale, evolution has its trials and triumphs. Quietly, over eons, this invisible garden of the ocean transforms the whole planet's atmosphere and prepares the stage for more complex beings to come. Slowly, life grows more complex. Within some single-celled organisms, smaller cells take up residence and become cooperative partners. The first mitochondria, giving their hosts more power. The first chloroplasts, allowing photosynthesis within a larger cell. These innovations usher in the first eukaryotes, more complex cells with internal organs. With them, life is no longer just tiny and simple. It now has the tools to build bigger, more specialized bodies. Some single cells begin living together in colonies, finding strength in cooperation. Over generations, these clusters become the first multicellular organisms, still microscopic and simple, akin to algae or tiny filaments floating in the water. The groundwork laid by their microbial ancestors provides oxygen to breathe and a stable environment to thrive in. These early multicelled beings spread through sunlit shallows, capturing sunlight by day and exhaling oxygen, a gentle exchange that keeps enriching their world. The quiet epochs roll on, and life's story advances inch by inch. Eventually, in the dim oceans of a time we call the Ediacaran, larger and stranger creatures appear. On a quiet seabed, an organism shaped like an oval leaf lies anchored in the mud, absorbing nutrients across its surface. Nearby, another creature resembling a quilted ribbon fans out on the sediment. These soft, alien-looking beings have no eyes or shells. Some stand upright like tapered pillars, others creep slowly across the sea floor. They are the Ediacaran creatures, the first large multicellular life forms on Earth. Though enigmatic and mostly motionless, they signal a crucial truth. Life is experimenting, trying out new shapes and strategies. These peculiar forms will eventually vanish, leaving only faint fossil imprints for future humans to ponder. But they mark a prelude to an approaching explosion of diversity. Then comes the dawn of a new era, a flourishing of life's variety that we call the Cambrian explosion. Imagine an underwater garden of astonishing richness, teeming with creatures of every shape and style. The seas suddenly swarm with life that can move swiftly, sense its world, and act in novel ways. It's as if nature, having quietly refined its tools for billions of years, suddenly bursts forth with creativity. There are translucent, frond-like jellyfish pulsing gently through the water. Worm-like beings burrow in mud, while others glide over the surface. Many creatures develop hard parts for the first time, shells and exoskeletons, adding a new element of protection and structure. One might see trilobites, those small oval creatures with segmented bodies and faceted eyes, scuttling along the seabed in search of food. Strange shrimp-like predators with grasping claws roam the waters, while spiny, slug-like grazers nibble on algae. Life's palette has expanded, painting the oceans with forms never seen before. In these Cambrian seas, evolution writes a vibrant poetry in flesh. A creature called Anomalocaris, as long as your forearm, glides by with undulating grace, its circular mouth and arm-like appendages seeking prey. Nearby, schools of the first primitive fish-like animals dart through sunlit waters, their backbones mere rods of cartilage, their senses simple but sufficient to navigate a world of hunt or be hunted. Among the multitude is a small, slender swimmer with a stiff rod running its length, a primitive notochord. This unassuming creature is the first chordate, carrying the blueprint for backbones. With a quick flick of its tail, it escapes a predator's grasp. From such humble origins will come fish, reptiles, birds, and eventually us. With life's rapid expansion come new roles and relationships. Predators and prey engage in an ancient dance of survival. Some creatures graze peacefully on fields of algae, while others become swift hunters, prowling the reefs. Ecosystems form, intricate networks where each being has a place. Tiny burrowers clean the seafloor, Filter feeders strain nutrients from the water, and scavengers recycle the remains of the fallen. The seas, once the domain of drifting microbes, now bustle with the silent commotion of countless animals. Coral-like colonies build the first reefs, creating nooks for small fish and shelter for soft-bodied animals. Snails and mollusks crawl and filter feed. Jawless fish wiggle through kelp forests. Every niche in the marine world finds an occupant. From the sun-warmed surface, where plankton blooms in green profusion, down to twilight depths where only faint light remains and strange pale creatures lurk. Picture yourself floating above a reef in these ancient waters. The ocean is clear, and pillars of sunlight dance down to the sandy bottom. To your left, a thicket of coral-like organisms sways gently, their tiny polyps extended to feed. Little fish, shining silver, weave in and out of this living labyrinth. To your right, a trilobite uses feathery legs to stir up sediment, scavenging for morsels. Overhead, perhaps a squid-like creature propels itself with jet pulses, its tentacles feeling for prey. The scene is peaceful yet vibrant, a testament to life's tenacity and inventiveness. The ocean has become a true ocean of life, full of breathing, wriggling, swimming beings that bring vitality to the once empty waters. For hundreds of millions of years, the ocean remains the center of life's story. Every major group of animals we know today traces its lineage to these waters. Life tries form after form, with evolution's tinkering producing an array of body plans. Some lineages flourish and diversify, others reach dead ends and disappear. There are setbacks too, occasional cataclysms where volcanic eruptions or climate shifts upset the balance, causing extinctions that prune the tree of life. Each time, life rebounds, often with new resilience and innovation. It is as if the living ocean has a resilient spirit, learning from upheaval, then surging back anew. In the shallows along coastlines, thin green mats of algae and early plants quietly prepare the way for life's next great expansion. They too have been evolving, from simple filaments clinging to rocks to sturdier forms that can survive the ebb and flow of tides. Some manage to endure brief exposures to air when water recedes. With each low tide, they soak in sunlight and stay moist just long enough to survive until the waters return. Bit by bit, these pioneers inch farther onto land. When they die, they decay into organic material, creating the first thin soils on barren rock. Over countless generations, these early plants transform shorelines, making a foothold for future life. The edges of the land turn a subtle green. Life, having mastered the seas, is testing the door to an untouched world above the waves. For eons, the vast continents of Earth knew no footsteps or birdsong, only winds, rivers, and the shifting of rocks. Yet life had been stirring at the margins. Along tidal flats and swampy inlets, hardy green algae pushed the limits of endurance. In periods of low tide or drought, these plants struggled, but some survived, evolving adaptations to resist drying out. From their simple forms arose the first mossy carpets on damp ground and tiny root-like structures anchoring into the new soil. The land was no longer completely barren. A delicate green film began to spread. With the advent of true land plants, everything starts to change in the grandest way. These pioneers break down rock into richer soil, trap moisture, and create pockets of nutrients. Lichens crust over stones, mosses hug wet surfaces, and fern-like plants unfurl in marshy hollows. They also release oxygen directly into the air, and add organic matter to the ground as they live and die. In their humble way, they are terraforming the continents, making the ground itself more hospitable for those who might follow. In time, these small plants give rise to taller, woody varieties. Along ancient riverbanks, the first primitive trees lift their fronds. Giant horsetails and towering club mosses form Devonian swamps, their slender trunks reaching for sunlight. They reproduce with spores, releasing tiny dust-like grains into the wind. Later, some plants evolve a new strategy: the seed, a protected, nourishing vessel for a developing plant. With seeds, forests can conquer drier interiors, as the next generation can wait out harsh seasons before sprouting. Soon, vast forests of ferns and early seed plants blanket the land, drawing down carbon dioxide and pumping out oxygen. As the plant kingdom marches inland, the animal kingdom is not far behind. In the ancient seas, certain creatures have already tested the boundary of water and land. Among them are arthropods, invertebrates with hard exoskeletons, such as primitive scorpions and millipede-like critters that crawl onto muddy shores to scavenge or escape aquatic predators. Over generations, some of these arthropods become more comfortable out of water. They breathe air through rudimentary lungs or through moist skin. They explore the new terrestrial frontier, feeding on decaying plant matter or hunting the few other pioneers present. Thus, the first land animals take their tentative steps. Meanwhile, in shallow lagoons and swamps, some fish are undergoing remarkable transformations. Certain fish, living in oxygen-poor water, evolve the ability to gulp air into an organ akin to a lung. Some develop stronger, muscled fins that allow them to push along the bottom, or even drag themselves for short distances over mudflats. One can imagine such a creature, fish-like, but with limb-like fins, propping itself up in the shallows, peering onto land. Over time, these sturdy finned fish give rise to true amphibians, animals that can live in water and venture onto land. They are the first vertebrates to know the feeling of solid ground under their bodies. Picture one of these early amphibians on a humid evening. In the fading light, it heaves itself out of a pond, its broad paddle-like limbs slapping wetly on the mud. Its skin glistens, and it breathes in the strange new air with primitive lungs. For the first time, this creature can peer around at a landscape beyond water, tangles of mosses and ferns, and perhaps skittering insects. The setting sun paints the sky in hues of orange and purple, colours no aquatic eyes ever needed to perceive. Overhead, the evening star emerges. Under this alien sky, the little amphibian rests, its body still mostly tied to the water, but its curiosity sensing new possibilities. In eons to come, its descendants will roam far from water, but for now, it takes only a few cautious steps before returning to the safety of the pool. Still, something profound has happened. A bridge between worlds has been crossed. As amphibians spread and multiply in the carboniferous swamps, the plant kingdom surges ahead in tandem. The low, creeping plants of old give rise to true trees. Immense forests thrive in the warm, moist climate. Giant tree ferns and towering scale trees, ancestors of modern club mosses, create dense canopies over waterlogged ground. The atmosphere, now rich in oxygen, reaches levels higher than today. In these conditions, arthropods grow to astonishing sizes. Dragonflies, with 2-foot wingspans, dart among the giant tree trunks, preying on other insects. Millipedes, as long as a human arm, coil beneath rotting logs. In shallow forest pools lurk amphibians the size of crocodiles. The world thrums with the sounds of life, the buzz and click of enormous insects, the croak of primitive amphibians echoing in ferny dells, the whisper of a warm wind through ranks of towering fronds. Over millions of years, some amphibians venture further from the waterways, adapting in ways that birth a new class of life, the reptiles. Unlike amphibians, which must return to water to lay soft eggs and keep their skin moist, reptiles evolve eggs with protective shells, little self-contained ponds that can be laid on land. This frees them entirely from the water. Their skin grows scaly to retain moisture. With these innovations, reptiles spread into drier regions, claiming the interiors of continents for the first time. Broad sun-soaked plains and uplands now have their animals. Lizard-like creatures basking on rocks, turtle-like beings plodding through the undergrowth, quick-footed predators snapping up the big insects and smaller amphibians. As time marches on, reptiles diversify and grow in stature. They master the land in a way no others had before. In the Permian period, the last phase of the Paleozoic era, the dominant land creatures are not dinosaurs. They haven't evolved yet, but mammal-like reptiles. Imagine a dry, scrubby plain under a glaring sun, where stocky, sprawling creatures like Dimetrodon, a reptile with a tall, sail-like fin on its back, hunt and thermoregulate by basking in the sunlight. These strange beasts, some with hints of fur, would one day give rise to mammals. But for now, they share the earth with hefty armoured parasaurs, munching on tough plants and wolf-sized predators prowling ancient conifer forests. Earth's landscapes have grown richly populated with life, from swampy lowlands to arid uplands. Life's story on land, however, is not without its catastrophes. Roughly 252 million years ago, a catastrophe strikes, a series of colossal volcanic eruptions in what will one day be Siberia. For years on end, fire and ash pour into the skies, blocking sunlight. The climate swings wildly. The oceans become acidic and deprived of oxygen. This cataclysm triggers the end Permian extinction, the greatest mass extinction Earth will ever witness. An overwhelming majority of marine species vanish, and most land species perish too. The lush, carboniferous forests give way to sparse landscapes, where only hardy survivors cling on. The world falls eerily quiet. It is a pivotal silence, as if life holds its breath. Yet even this nearly mortal blow is not the end of life's tale, only the end of a chapter. Slowly, over millions of years, the earth recovers. The intense volcanism subsides. The skies clear, and life creeps back from the brink. In the Triassic period that follows, new lineages take root. Out of the shadow of disaster emerge the first true dinosaurs, initially small, nimble creatures darting on two legs. Alongside them are early relatives of crocodiles, frog-like amphibians in rejuvenated rivers, and survivors of the cataclysm, like the stout, tusked Lystrosaurus that roam the open scrub. The world is ready for renewal. By the Jurassic period, dinosaurs have risen to astonishing prominence. Forests of ginkgos and conifers ring with the calls of these reptiles. Towering herbivores with long necks browse the treetops, their massive bodies shaking the ground with each step. Fearsome carnivores stalk them, moving through dappled forest light with predatory grace. Horned and plated dinosaurs appear, displaying elaborate frills and spikes, perhaps as much for show as for defense. Diverse forms fill every niche. Some dinosaurs roam in great herds across floodplains, while others prowl dense jungles in solitary ambush. There are even those that take to the skies. Pterosaurs, winged reptiles, launch themselves from cliffside nests, gliding on leathery wings above primeval coastlines. Some are small as sparrows, snatching insects on the wing. Others are giants with wingspans the length of a car, casting shadows on the ground like passing clouds. Under the sun's bright gaze and the soft glow of ancient starlight, Earth's landscapes teem with life once more. We can imagine a night in the late Jurassic. The air is warm and filled with the chorus of insects and distant calls of nocturnal creatures. A full moon rises, silvering the broad leaves of tree ferns. In the marsh below, a massive herbivore, something like an apatosaurus, settles its bulk into a resting spot, causing a hush as smaller creatures scurry away from the gentle disturbance. High in a cycad tree, two small feathered dinosaurs, early birds, shift on their perch, silhouetted against the moonlit sky. They tuck their heads under wings to sleep, while far off, the resonant hoot of a primitive ancestor of owls echoes. The constellations above are the same, yet no mind here can chart them. The cosmos keeps silent watch as it always has. The stars that will one day guide human navigators now shine upon the backs of sleeping dinosaurs and the flutter of prehistoric moths. The world beneath those stars is alive and vivid, but the appreciation of the cosmos's beauty must wait for other eyes. In the late Cretaceous period, flowering plants emerge, adding new colour and fragrance to the world. Bees evolve to gather nectar, forming a partnership with flowers that will persist to our time. Dinosaurs adapt to this changing flora. Massive herbivores wander through meadows of blooming magnolias and lilies, and smaller creatures nibble fruits and carry seeds far and wide. Life seems secure in its dominion. But another upheaval approaches, one that, in an instant, will end the age of dinosaurs. On a regular day, under a bright midday sky, a brilliant point of light suddenly appears high above. It grows rapidly, outshining the sun in its descent. This is an asteroid, several miles wide, on a collision course with Earth. Within moments, it strikes near what will one day be Mexico. The impact is catastrophic beyond imagination. It blasts a crater over 100 miles across, vaporizing rock and ocean alike. A searing fireball roars outward, and shockwaves circle the globe. In the immediate aftermath, forests ignite thousands of miles away. Then a long darkness descends. Dust and soot fill the atmosphere, blotting out sunlight. For months, perhaps years, Earth endures a chill and gloom that halts photosynthesis. Plants wither, plant eaters starve, predators find no prey. One by one, the mighty dinosaurs falter and die, save for a few small bird-like ones perched in sheltered hollows. The reign of the great reptiles, which lasted over 150 million years, comes to an abrupt end. But life, tenacious as ever, finds a way to survive on a smaller scale. Many of the victims are gone, but in the quiet after the fury, a few hardy forms begin to reclaim the world. For a while, ferns dominate the land, springing up in carpets over ash-covered ground. pioneers of a ruined landscape, as they have done after each cataclysm. Insects buzz among the ferns, and amphibians croak in newly formed ponds. In burrows and darkened corners, the small mammals that once scurried underfoot during the dinosaurs' reign now emerge into an open playing field. Mammals, once minor players, living in the giant's shadow, begin to flourish in this new world. These warm-blooded, furry creatures had coexisted with dinosaurs for over 100 million years, mostly as tiny nocturnal insect eaters or seed gatherers. Now, with competition greatly reduced, mammals radiate into a stunning variety of forms. Some remain small and nimble, darting through underbrush as mice and shrews. Others grow larger and more daring, taking up the roles of grazers and predators left vacant. In the dense forests of the Paleogene period, the epoch after the dinosaur extinction, mammals diversify into myriad new species. There are ancestral primates climbing in the canopy, their grasping hands and keen eyes perfect for arboreal life. There are odd-hoofed creatures browsing on leaves in the shadows, early relatives of horses and deer. Along broad rivers, snouted animals wallow and fish, foreshadowing creatures like tapirs or elephants. And remarkably, some mammals venture into the water, reclaiming the seas for the mammals. Small-hoofed predators begin a transition that will, over millions of years, turn them into whales. Birds, the surviving dinosaurs, also flourish and evolve into new niches. Some become great flightless hunters, stalking plains, others brilliant songbirds flitting among flowering trees. The world that emerges is different, but no less vibrant. Lush rainforests cover much of the planet, hosting early monkeys, colourful birds, and countless insects. In the cooler regions, new grasslands will eventually appear, and with them, herds of grazing mammals and quick-footed carnivores. Life has rebounded in a dazzling array, proving once more its resilience. One could almost sense the earth itself heave a sigh of relief and renewal. One lineage of mammals, the primates, thrives in tropical forests. They are adept climbers, living among the branches, eating fruits, leaves, and insects. For tens of millions of years, these early primates flourish in the warm embrace of the trees. But climates continue to change over time. In parts of Africa, those lush forests begin to thin out, breaking into patchy woodlands and savannas. In this changing landscape, some primates face a new challenge: fewer trees and more open ground between them. Around 6 or 7 million years ago, a group of primates responds to this challenge in a way that will alter the course of life on Earth. They begin to walk upright. Initially, perhaps they stand to peek over tall grass, or to reach for fruit on high branches. Over generations, their skeletal structure shifts. Hips, spine, and skull accommodating an upright stance. Their hands, freed from walking, become more deft at grasping and manipulating objects. They are the early hominins, the first of our lineage to regularly walk on 2 legs under the open sky. At first, these beings still resemble their ape cousins in many ways. They likely spend nights in trees for safety and retreat to the woods whenever danger lurks. They gather fruits and nuts, and perhaps scavenge the kills of larger predators on the savannah. They travel in small bands, cooperating for protection. With each generation, they become a little less ape-like in gait and more adapted to life on the ground. Their brains begin to grow in size relative to body weight, and their curiosity leads them to explore new ways of obtaining food. Across the following millions of years, many different human-like creatures walk the earth. Some species come and go, each with its own adaptations. They learn to shape stone into tools, to spark and tend fire, to hunt together in coordinated groups. By around 300,000 years ago, our own species, Homo sapiens, has emerged in Africa. These early humans are physically modern in many respects. They have the build of people you might see today. And crucially, they have brains capable of complex thought, language, and imagination. With those gifts, they stand truly apart from all who came before. Night has fallen on the African savanna, perhaps 100 millennia ago. Beneath a sky ablaze with stars, unmarred by any artificial light, a small family of Homo sapiens huddles around a crackling campfire. The flames cast a gentle orange glow on their faces and flicker in their dark, reflective eyes. This simple scene, a circle of people around a fire, is quietly revolutionary. Fire gives them warmth against the chill of night, protection from prowling beasts, and a gathering place for sharing, not just food, but ideas. By day, these early humans move through their world with purpose and curiosity. They track game across golden plains, reading footprints in the dust and broken twigs as clues. They gather roots, tubers, and berries, recalling by memory which plants nourish and which harm. They cooperate to chase prey into ambushes or to drive scavengers off a carcass. Every experience teaches them something new, and they store that knowledge in their minds, and crucially, share it with each other through gestures and speech. When the sun beats down at midday, they rest under the shade of acacia trees, perhaps napping a flint stone into a sharper tool, or simply reflecting in silence. But when evening comes, and work subsides, their thoughts turn to deeper mysteries. As the horizon glows red and purple with sunset, they return to their fire, to safety, to companionship, and to the fertile realm of imagination. Listen closely as the flames dance and the first stars emerge overhead. You might hear their soft voices mingling with the pops of burning wood. They are speaking to each other in a true language. The exact words are unknown to us, but these people can convey not just commands or alerts, but ideas and feelings. Around this fire, they do something no creature on earth has ever done before. They share stories. They can describe the hunt of the day, the thrill of the chase, the one that got away. They can plan for tomorrow, where the herds might go, how to prepare for the coming rains. Most wondrously, they can create. An elder, with lines of wisdom on her face, begins to hum a gentle melody. Another taps a hollow log rhythmically with a stick. A young man produces a flute carved from an animal bone, pierced with holes, and as he blows, a haunting tune floats into the night air. The others listen, some swaying, some closing their eyes. In that moment, the group is bound not just by need and blood, but by shared experience, by art. Beside the fire, a small child points upward at the glowing band of the Milky Way arcing overhead, a river of stars so bright out here, far from any other light. Her eyes are wide with wonder. She asks a question, perhaps using the few words she has, or maybe just tugging the elder's hand and gesturing to the sky. The elder understands the question. What is that? Everyone falls quiet, faces turned toward the sparkling heavens. The elder decides to answer not with a shrug of ignorance, but with a tale, because humans are becoming storytellers. She speaks in a calm, rhythmic voice as the others lean in. She says that long ago, the sky was dark and empty. The people were afraid to travel at night because there was no light to guide them. Seeing this, a wise spirit took pity. He climbed a high mountain, carrying a sack of bright embers from the first fire. When he reached the top, he flung the embers across the firmament. They scattered into the darkness and stuck there, creating the milky band of light that arches across the sky. That is the Great Path, a guide for all who wander. The spirit made it so that no matter where his people went, they could always find their way home under those stars. The child gazes up, imagining embers becoming stars. The others murmur in appreciation of the familiar story, for perhaps they have heard it before. In this act of storytelling, something profound unfolds. The raw facts of the world, the lights in the sky, are woven with meaning and comfort. The unknown becomes a canvas for the human mind, turning fearful darkness into a guiding light. They sit around the fire a while longer, trading stories and thoughts. Perhaps they discuss the sounds of distant thunder or the roar of a lion heard across the valley, attributing them to spirits or mythical creatures. They might share memories of a loved one who died last winter, wondering if that person's spirit lives among the stars now. Their language allows them to time travel in a sense, recalling the past, envisioning the future, and conjuring things that don't physically exist. The flickering fire pushes back the surrounding darkness, just as their imaginations push back the darkness of unknowns. Their capacity for imagination is also visible in other ways. Deep in a cave by firelight, some of them have painted images of the animals they hunt. Great ochre bison and charcoal horses gallop across stone walls, brought to life by artistic hands. Perhaps these paintings are part of a ritual, or perhaps an early form of storytelling, capturing the essence of a creature to honour it or to ensure success in the next hunt. At other times, they have carved pieces of ivory and bone into shapes, a small figurine of a half-human, half-lion being, a creature of a dream or a legend, or beads to wear as adornment. On special days, they decorate their bodies with red ochre and black charcoal, maybe to signal roles, or simply to feel beautiful and ceremonial. These creative expressions show that their inner world is rich. They don't just live, they interpret, symbolize, and aspire. As the night deepens, the voices around the campfire grow quieter. The children nod off, one curled against her mother's side, another wrapped in a fur. One by one, the adults fall into a thoughtful silence, each gazing at the embers or the stars. Perhaps one man, a watcher for the night, stays awake while the rest sleep in a huddle of warmth. He stares into the cosmic ocean above. The Milky Way glows, and meteors streak occasionally. Silent fireworks of the gods, he might think. In the profound quiet of that moment, he feels something stir inside. A mix of awe and peace. He does not have a word for cosmos or philosophy, but he experiences the emotion of them, the sense of being a small part of a vast, unknowable expanse. In his breast, under the same stars that you and I can see today, the first glimmers of a spiritual sense flicker. He might feel the presence of ancestors in the sky, or perceive patterns that tell him the sky itself is a storybook written by divine hands. Our early humans are becoming fully conscious in a modern sense, not only reacting to the world, but reflecting on it. They likely begin to bury their dead with care, suggesting they wonder about life beyond life. They perform small rituals, a dance to invoke rain, or a whispered thanks to the spirit of a deer that provided meat. These actions show an understanding that there are forces bigger than themselves, and a desire to connect with those forces through imagination and ceremony. Over many generations, these bands of humans expand their horizons. They follow animal herds and wander to new places. Eventually, they spread out of their African cradle to every corner of the habitable world. They trek through verdant river valleys, venture across arid deserts, endure frigid ice age tundras. They discover forests blanketed in snow and ice. During the height of the ice ages, those who live in the shadow of glaciers learn to sew warm furs and build sturdy shelters partially underground. They keep fires alive through months-long nights, and they find sustenance where everything seems barren, digging up edible roots beneath the frost or following herds of reindeer across frozen plains. These challenges demand ingenuity and bind them even closer together. In overcoming the harsh cold, they deepen their social bonds and spark new inventions like tailored clothing and food preservation that will serve humanity for ages. Wherever humans roam, they carry their wonder with them. If you could take a bird's eye view of the planet in a single moment during this era, you might see countless points of fire dotting the darkness, each a camp or village where people gather under the night. The descendants of those first fire-lighting humans have spread far and wide, reaching forests, mountains, and coasts thousands of miles apart. Yet wherever they travel, they tend the glow of a campfire and share stories of the sky. Under unfamiliar constellations in a new land, they find comfort in remembering the old tales or inventing new ones for the stars they see. In this way, the ancient bond between humanity and the heavens only grows stronger, forming a golden thread of shared myth and memory, stretching across continents and ages. At one camp in a temperate woodland, elders teach the youth about the stars directly. A grandfather, his hair silvered with years, points out a particular grouping of stars to a circle of attentive children. In his mind, those stars form a mighty hunter, and he recounts how that hunter chases a great beast across the sky every night. Far to the north, on an icy plain, another group watches ribbons of aurora light, curtains of green and red flickering across the polar sky. And they weave myths of animal spirits dancing, or ancestors sending messages through the night. Near the equator, under a different sky, families gaze up at a cross-shaped constellation and see in it a celestial tree, its branches laden with stories of creation. Across the world, countless eyes look up in wonder, and countless stories bloom. Many early peoples develop rituals tied to the sky's rhythms. When a certain star first becomes visible at dawn after months of absence, it might signal the time to move camp or prepare fields for planting. One culture notices that when the small cluster of stars we call the Pleiades rises just before sunrise, the dry season is ending. Time to sow seeds in anticipation of the rains. In another land, the first sighting of a bright star, Sirius, at dawn each summer, heralds the flooding of a great river, a life-bringing event. These practical observations blend with myth. Perhaps they believe a star god brings the flood, or the appearance of the Pleiades is the lantern of a celestial farmer starting his planting. Patterns become predictions, and those predictions in turn, reinforce the sense that the cosmos is intimately tied to their lives. No matter the latitude or landscape, the sky serves as compass, calendar, and canvas. Early navigators learn to follow the stars to cross unmarked seas and trackless terrains. A canoe of islanders setting out at dusk waits for a familiar star to rise, knowing it will guide them toward a neighboring island beyond the horizon. Desert nomads fix their travels by the unmoving star in the north, using it to hold direction through featureless dunes. The sky is reliable when Earth is not. A north star remains fixed. The seasonal stars return each year on schedule. Such knowledge is passed down in songs and chants, easy to remember and rich with encoded information. In one culture, a song names stars in the order they appear through the night, doubling as a navigation path across an ocean. In another, a tale of a celestial hunter and a celestial lion not only entertains, but also teaches the months those constellations dominate the sky, hinting at the timing of rains and migrations. We can imagine towards the end of the Stone Age, human societies beginning to build lasting markers of their celestial knowledge. On a broad plain, people raise great stones in a circle, aligning them so that on the year's longest day, the sunrise casts a beam of light through a particular gap. On another continent, they construct an earthen mound, precisely oriented to capture the light of the winter solstice sunset deep into its chamber, perhaps to beckon the sun's return on the darkest day. In a desert land, pyramid builders angle their monuments so that a certain star can be seen straight down a passage, believing it to be a gateway for the pharaoh's soul to ascend to the heavens. These feats require careful observation and a deep reverence for the sky's cycles. On the longest night of winter, one community gathers in a clearing around a circle of stones they've laid out. They ignite a great bonfire in the center, its flames roaring upward. All night, they feed the fire, dancing and singing softly, their shadows flickering against the snow. They do this to honor the sun at its weakest moment, believing their light and warmth will help the sun regain strength. As dawn finally breaks after that darkest night, they watch the horizon with held breath. When the sun's first rays peek through the trees, the people cheer and weep with relief and joy. The long night has turned a corner. The days will grow longer now. Such solstice rituals, or others like them, appear in many cultures, a testament to how attuned our ancestors were to the sky's rhythms and how they met the uncertainty of nature with ceremony and hope. Through stories and rituals, the stars become more than distant lights. They are family. A constellation might represent a beloved ancestor, and seeing it rise could feel like greeting an old friend. The moon might be a gentle grandmother figure, its phases telling a story of death and rebirth each month. The sun might be a vigorous father, reliably returning each day to watch over the world. By personifying these celestial bodies, early humans fold the cosmos into their community. It becomes not a cold, impersonal expanse, but a realm filled with familiar faces and intentional acts. To lie beneath that sky was to feel both insignificant and incredibly special at the same time. Insignificant because the stars hinted at an enormity in which one human life was but a flicker. Special because they believed those stars overhead were placed there with purpose, perhaps even for them. This blend of humility and belonging became a cornerstone of human spirituality, Under the grand dome of stars, each person might feel small, but also feel that they mattered in some scheme of things. The night sky unified them, just as the fire did. No matter their differences or daily struggles, everyone shared the experience of wonder when looking up. In that way, the sky fostered a profound sense of unity among people. Around the fire, they felt like one family. Under the stars, they felt like one part of a vast, meaningful design. All the while, practical knowledge and rich imagination merge seamlessly. The stars and their movements are carefully observed and recorded in memory, but they are also woven into the fabric of myth. If certain stars vanish seasonally because of the sun's glare, a story might say they are visiting the underworld and will return. If a bright comet unexpectedly streaks across the sky, it could be seen as an omen, perhaps a trickster spirit, or a warning of change, and communities would gather to interpret its message through the lens of their lore. In these ways, early humans turned the random events of nature into purposeful narratives, giving themselves psychological comfort and communal guidance. As centuries and millennia pass, these early patterns of understanding lay the groundwork for human civilization. The knowledge of the stars that guided nomads will guide farmers and sailors. The spiritual awe felt under the night sky will find expression in temples and scriptures. The gentle connection, feeling that the universe is speaking to them through the rustle of leaves or the glow of constellations, will persist even as cultures grow more complex. The living earth has nurtured not only creatures that breathe and walk, but also minds that wonder and dream. For those first stargazers by the campfire, the journey was only beginning. In millennia to come, their descendants would domesticate plants and animals, give rise to villages and great cities, and eventually gaze at the heavens with new tools and questions. They would sail seas by starlight and later send machines beyond the atmosphere to touch the moon and planets. The story of the living earth would merge with the story of human civilization, science, and exploration, a new chapter in the grand saga. But that chapter lies ahead. For now, we rest in the gentle darkness before dawn, content in the knowledge that we are part of this ancient tale. The calm and wonder we feel under these stars is a gift handed down from our earliest ancestors. As night slowly yields to day, the sky lightens, but the stars do not vanish. They merely wait beyond the blue, ever present. So too, the sense of connection and curiosity kindled in those first dreamers continues to glow within us. In the next light of morning and in the chapters to come, we carry that inheritance forward, the quiet awe of living on a magical world in a universe full of mystery. Our journey through the cosmos has carried us across countless wonders. Luminous, ethereal nebulae, swirling galaxies, and distant worlds. Now, as we drift further into the quiet, star-washed reaches of space, a gentle cosmic silence surrounds us. The stars glimmer like distant lanterns set in a deep velvet expanse, and the band of our Milky Way arches overhead like a faint, glowing river. With no sound but the beating of our hearts and the whisper of our own thoughts, we feel truly afloat in the cosmic ocean. In this stillness, the vastness and mystery of the universe invite a deeper, more contemplative reflection. We find ourselves not just observers of the stars, but participants in a grand cosmic story, entwined with the very fabric of the night sky. Beneath an endless vault of stars, a sense of cosmic consciousness awakens. It is a subtle awareness that we who gaze up at the galaxies are made of the same luminous dust that twinkles above. The atoms that form us were born in ancient stars, and in our minds flickers the light of those long vanished suns. We are more than small beings lost in the void. We are the universe itself, perceiving its own immensity through human eyes. On a moonlit night, far from city lights, one can lie back on cool grass and feel the infinity overhead. The Milky Way spills across the sky, and in its silvery glow comes a whisper of connection. Each star above is a distant sun, and around some of those suns may circle planets with their own seas and skies. Perhaps on a faraway world, under an alien sky, another soul looks up and feels the same wonder. They might have two moons or a sky tinted in unfamiliar colours, but the stars above spark a familiar question in their heart. In their own way, they wonder if someone else is out there, just as we wonder about them. For that distant observer, we are part of the mystery of the universe, just as they are for us. In that thought, the cosmos seems to grow smaller and more intimate, like a neighbourhood of houses under one shared sky. We do not yet know whether such distant neighbours truly exist. The universe is silent, so far about other beings. If, in the vastness of space, we are the only ones who have awakened to awareness, then our role is singular and profound, to be the universe's lone conscious voice, cherishing that gift of insight. If, on the other hand, the cosmos is teeming with life, then one day our awareness may meet another's, and the universe will know itself in a new, collective way. Either possibility fills the heart with wonder. In the meantime, the night sky keeps its quiet secrets, and we continue to send out our thoughts and probes as greetings in the dark. With each message and each listening ear turned skyward, we affirm hope that we are not alone. And even if we are, the cosmos we are a part of is rich enough in marvels to keep us company. This feeling of unity can arise in quiet moments. As you inhale under the night sky, the air filling your lungs carries atoms exhaled by trees and ancient forests. Atoms that have drifted through clouds and across oceans to reach you. Those atoms have been part of countless forms of life before finding their way to you. In the same way, the starlight that falls gently on your face has travelled years or millennia to reach this moment. When it touches you, you become the meeting point of past and present, of distant stars and the earth beneath you. A calm sense of awe and reverence may dawn. You are an essential part of this vast, unfolding cosmic tapestry. We often think of the universe as something outside and separate, a panorama we observe from a lonely shore. Yet consider that the boundary between out there and in here is delicate. The photons from a star enter your eyes and become tiny electrical signals in your brain. In that instant, a piece of a star has become part of your inner world of thoughts and feelings. The cosmos pours into us ceaselessly through every sensation and every breath. In turn, we project our dreams and questions out into the cosmos, sending probes and prayers, radio signals, and radiant hope. There is a continuous exchange, a conversation between the universe and our own awareness. In the stillness of a clear night, such thoughts flow naturally. One might recall lying by a crackling campfire under a canopy of stars, feeling both incredibly small and profoundly connected. The stars seem to listen to the quiet of your mind. In that silence, you may sense that your own consciousness is like a mirror, reflecting the cosmos back to itself. After all, every idea we have about the stars comes from within the mind that evolved here on Earth. A tiny world orbiting a modest star in a galaxy among billions. And yet that tiny mind can envision the entire cosmos. It can ponder eternity and infinity, as though inside us we hold an echo of the boundless skies. Across time, humans have wondered if the universe itself could be conscious in some way. When we look out at galaxies swirling like giant storms of stars, some have imagined those might be the thoughts of a cosmic mind. This may be just poetic fancy, but it springs from a real sense of mystery and wonder. We find consciousness in ourselves to be the most immediate reality. We know we are aware, even if we do not fully understand how. And we see the organized complexity of the universe, from galactic clusters down to living cells. And we wonder, is it all mere coincidence? Or is there an underlying awareness threading through the cosmos? Science does not yet have an answer to the deepest questions of consciousness. But on a calm night, under the stars, one does not need an answer to feel a connection. It can feel as if the cosmos knows you, in the simple fact that it made you. The carbon in your muscles, the calcium in your bones, the iron in your blood, all were forged in the hearts of stars that lived and died billions of years ago. Those stars are gone, but a part of them now thinks and feels and looks up at the sky again. In that sense, the universe has recycled itself into living form capable of awe. Through our eyes, the universe gazes at its own ancient light. Through our ears, it listens to the cosmic silence and peace. In our hearts, it perhaps feels a little of its own immensity. Consider a single speck of iron in your blood, an atom riding within a red blood cell on its circuit through your veins. Where did it come from? Long ago, that iron atom was forged in a star's core in a fantastically hot furnace. When that ancient star reached the end of its life, it exploded in a brilliant supernova, scattering its elements into space. That iron atom drifted through the galaxy as part of a gas cloud for millions, or perhaps billions of years. Eventually, that cloud became part of a new star system, our solar system. In the young Earth, that atom mingled in rocks and soil. Through geological ages, it might have been washed into the ocean, or drawn up into a plant, and then eaten by an animal. Ultimately, it found its way into your body, perhaps in the food you ate or the water you drank. Now it travels inside you, helping to carry oxygen to your cells. In time, when your journey of life is complete, that iron will return to the earth, and maybe far future generations, or even new worlds, will carry it onward. This one tiny atom has crossed the cosmos and time to be part of you, a bridge between your life and the stars. Multiply that story by trillions, for every atom in you has a tale as astonishing. Realizing this, the line between you and the universe starts to blur, as indeed it should. This perspective can bring both comfort and curiosity. If we are the universe aware of itself, then when we love, when we create art, when we explore, it is the cosmos expressing those very things. Every poem written about the stars, every equation scribbled to understand gravity, every lullaby sung to a child under the night sky, they are acts of the cosmos understanding and cherishing itself. We often feel so separate and small, but in truth we carry the universe within us. Not just in the physical sense of star stuff, but in the sense that our capacity for thought and emotion is as natural a part of the cosmos as the burning of a sun or the orbit of a planet. Picture the first humans who realized that those tiny lights above are not just holes in a dark curtain, but distant suns. Imagine the amazement and perhaps the fright they must have felt, sensing suddenly that the world is so much larger than it seems. But with that realization also comes a profound opportunity for humility and connectedness. To know that the atoms of our bodies come from the stars can instill a sense of belonging in the universe. We are children of the cosmos, made from its raw elements, and to it we shall return when our life ends and our atoms disperse to become new forms. This cycle of matter is like a great wheel turning slowly over eons, life and death, stars and galaxies, all bound together. So on this journey, as we float through the quiet starlit void, consider that you are both a traveller and at home. You travel through space on a tiny planet, yet you also carry within you pieces of every place you have ever been. In a way, you are home to particles of distant stars and perhaps even distant galaxies, which drifted and eventually became part of Earth. The cosmos is not just around you, it is within you, sleeping in your cells, awakening in your thoughts, and breathing in your breaths. With each gentle inhale and exhale, you trade atoms with the air and the world, blurring the lines between you and the outside. Over a lifetime of breaths, you will inhale trillions of atoms that once belonged to others, other people, other creatures, even other worlds. The same is true for them, inhaling what was once part of you. In this great exchange, the universe mingles with itself, all things sharing the same cosmic air. This awareness can be a kind of meditation. Breathing becomes not just a simple act of survival, but a communion with ancient elements. Looking at the stars becomes not just sightseeing, but greeting ancestral lights that are kin to our very substance. A gentle breeze on your skin at night might remind you that the atmosphere wrapping around our world is itself a product of life, interacting with cosmic forces. The oxygen from ancient trees, the nitrogen from distant cosmic events, all blending to cradle us. We are cradled not only by the earth, but by the cosmos at large. Starlight, gravity, and elemental cycles nurture us each moment. And in gratitude, we pay attention. We listen to the night. The cosmos has a way of inviting our attention inward, even as we gaze outward. In the darkness, as your eyes adjust, more stars emerge from hiding. Likewise, as you become still, thoughts settle, and a deeper sense of self can emerge from within. It is in those moments that the concept of cosmic consciousness becomes more than an idea. it becomes a felt experience. Perhaps you notice that your heartbeat is steady and calm, echoing gentle rhythms found everywhere in nature. The pulsing of crickets in the dark, the slow flare of variable stars. You might sense that your mind, quieted, is as vast as space itself, with thoughts appearing like distant twinkling stars in the expanse of your awareness. This state of calm, serene reflection, where inner space and outer space seem to touch, is a precious experience. Many seekers of truth, philosophers and monks and poets and scientists alike, have spent nights under the sky seeking that sensation. Some have described feeling dissolved into the stars, where the boundary of self falls away, and only unity with all things remains. Others have found in the cosmic view a perspective that heals, an understanding that our troubles and worries, however heavy, exist in a much larger tapestry of existence. Not to diminish the importance of our lives, but to realize that we are part of something vast and enduring can make those burdens easier to bear. It is as if the stars quietly say, "You are not alone. You are part of this great story." Even the silence out here feels alive with meaning. Drifting in the cosmic ocean, one can sense the echoes of ancient explosions, the glow of faraway suns, and the soft presence of unseen matter that gently sways galaxies. We know through science that space is not truly empty. It's filled with invisible fields and particles popping in and out of existence. But even without knowing those details, one can feel that emptiness is full of possibility. In a way, the darkness between stars is like the silence between notes of a lullaby, integral to the music, giving it depth and resonance. The quiet of the cosmos is the canvas on which all celestial light is painted. In this serene hush, a question naturally arises. What does it all mean that we are here, able to witness this grand tableau? It's a question both deeply personal and profoundly universal. Perhaps the meaning is simply to witness it, to marvel, to learn, to feel. Perhaps it is to connect, each conscious being a bridge between the stars, sharing in the universe's self-discovery. Or maybe meaning is a human construct, something we create to comfort ourselves in the face of infinity. And yet, even if that is so, there is comfort indeed. When you stand beneath the sky and feel awe and reverence, that feeling is its own justification. In that moment, nothing more is needed. You and the universe are in silent conversation, and that is enough. Our awareness, as small as it seems, becomes a precious vessel, carrying the universe's memory. In our minds, we hold the history of stars, the chronicle of how a universe coalesced into galaxies, and how, on at least one world, life emerged to see the stars. That narrative lives on as long as we remember and tell it. In a way, the cosmos ensures its own story continues by instilling curiosity in us. Every time you feel compelled to look up and wonder, it is the cosmos nudging you to remember where you came from. Each of us is a storyteller on behalf of the universe, whether we speak through science or art, or simple, gazing wonder. And so, as this reflection on cosmic consciousness flows gently onward, consider how extraordinary it truly is. For a few brief moments in cosmic time, the matter in these hills and oceans coalesced into beings who could feel love and wonder. For a brief era, there are eyes open to see the night, ears to hear the wind in the trees, minds to ponder existence. It may not happen everywhere or often in the universe, or perhaps it does. We do not yet know. But here and now, it is happening through us. By simply being aware, we fulfill something fundamental about the universe. We give it eyes and ears, thoughts and emotions. Out in the dark sea of space, our planet glows a delicate blue, alive with this awareness. If one could drift high above, one might see Earth as a small lantern of life, flickering with the collective light of billions of souls. Each soul is like a candle, and taken together they make a radiant glow that could be sensed if you were near enough. In that metaphor, humanity and all life on Earth are the cosmos gathered into a brief, bright island of knowing and feeling. And though each candle may eventually dim, others will light in succession, continuing the luminous chorus. The light of consciousness, once lit, has a way of spreading, just as one flame ignites another. It is calming to realize that we belong to this continuum. The cosmic perspective doesn't make us insignificant. It makes us invaluable participants in a cosmic unfolding. We may be tiny, but like a tiny neuron in a vast brain, we have our role in the grand awareness. And collectively, perhaps all conscious beings across the universe, if there are others, form a kind of network of awareness spanning the galaxies, even if we never meet them, even if those distances remain unbridged. Just knowing they could exist expands our sense of family. Under the same stars, in a different sky, others might wonder and hope, just as we do. The universe might be quietly full of such secret sparks of knowing. However, even if we are alone in our galaxy in this moment, that does not diminish the miracle of being here. In fact, it places a gentle responsibility on us to keep the flame of awareness alive, to explore and to cherish, to keep telling the universe's story so it won't be lost in silence. Each lullaby about the stars that we whisper to a child, each question we ask about the cosmos, each dream we have of distant worlds is part of that responsibility. It is how we honor the gift of consciousness that the universe has, through countless trials and wonders, given to us. Now, as we float further into this thoughtful night, let the sense of cosmic consciousness gently fade into the background like soft music. It will remain with us as an undercurrent. We carry that awareness onward as we turn to another layer of the cosmic mystery. Just as we have looked out into the vastness and felt a grand unity, we can also look inward into the minuscule and find wonders no less profound. Our journey continues seamlessly from the very large to the very small, for the two are connected like reflections in a mirror. At the smallest scales of existence, a new kind of mystery and wonder unfolds. As we shift our gaze from the immense to the infinitesimal, we enter the realm of the quantum, a world where the rules of everyday reality seem to fade into a dreamlike haze. Here, particles flicker in and out of being, and certainty dissolves into possibilities. In this microscopic domain, we find that everything solid is mostly empty space, and what we think of as matter is composed of tiny, flickering energies, whirling in vast gaps of apparent nothingness. It is as if the cosmos, when examined up close, is built not of bricks, but of whispers and probabilities. Imagine shrinking down into an atom, drifting past electrons that swarm not like neat planets around a sun, but like a diffuse cloud of potential, here and there at once, until observed. In this tiny universe within the universe, an electron can be almost everywhere and nowhere in particular. Only when we try to pin it down does it seemingly make a choice of where to be. This is the strange dance of quantum mechanics. Particles behaving sometimes like solid points, other times like spread out waves. A single speck of light, a photon, can act as if it travels many paths simultaneously, then settle on one path only when we look. Reality at this level is not a fixed storyboard, but an improvisation. A play of light and shadow that only becomes concrete when it interacts with a consciousness or measuring instrument. It's a realm that invites us to question what is real, and whether observation is somehow woven into the very fabric of existence. This isn't chaos, but a different kind of order, one that defies our common intuition. In quantum realms, cause and effect can feel less straightforward. Two particles born together can become entangled, a mystical bond connecting them no matter how far apart they fly. If one is gently nudged, the other responds. Even if it is across the room or across the galaxy, instantaneously, as far as we can tell. It is as though the universe keeps secret channels between distant things, a private whisper that ignores the vast gulf of space. Experiments have shown this spooky connection to be real. Einstein himself famously nicknamed it spooky action at a distance, acknowledging how unsettling such instant linkage was to him. Yet every experiment since has confirmed that this mysterious connection indeed exists. It suggests that separateness might be an illusion, and that at a fundamental level, the cosmos is deeply interconnected in ways we are only beginning to fathom. In the quiet of our journey, think of what this means. The very particles in your body might have subtle links to particles far away. Perhaps an atom in your hand is quantum connected to an atom in a star, a million light years distant. While the specifics of entanglement don't usually persist in our complex bodies, the idea symbolizes a truth, that everything emerged from the same cosmic beginnings. In the moments after the universe was born, all was one blazing soup of particles intermingling. As the universe expanded and cooled, those particles drifted apart to become galaxies, stars, planets, and eventually us. Yet on an underlying level, they remember a time when they were together as one. The echo of that unity may still live in the quantum language they speak. Not only distance, but time too behaves oddly in the quantum world. Particles pop into being and vanish, as if borrowing energy from the future and returning it an instant later. This constant fluctuation, sometimes called quantum foam, means even empty space is teeming with subtle activity. What appears as a void is more like a sea of virtual particles, momentarily alive then gone, like transient thoughts in the mind of the universe. Perhaps this is the source of creativity in nature, the way new possibilities emerge. From this foam, entire universes might have budded off, or the seeds of galaxies might have been sown. On a smaller scale, these tiny fluctuations are happening around us and within us all the time, unnoticed, yet essential. They provide a backdrop of possibility from which more stable things, like atoms and molecules, can form and persist. And within the heart of a star, quantum magic enables life-giving light. In the sun's core, where temperatures and pressures are immense, atomic nuclei fuse together, releasing energy that eventually radiates out as sunlight. But curiously, the nuclei in stars are often not energetic enough on their own to overcome their mutual repulsion. It is the quantum trick of tunneling, the ability of particles to slip through barriers as if by ghostly permission, that allows the sun and stars to shine. Two hydrogen nuclei can fuse into helium because in the quantum realm, there is a small chance they simply find themselves together, bypassing the usual obstacle. Without this tiny chance, the stars might never ignite, and the cosmos would be dark and lifeless. Thus, the everyday sunshine that warms your skin is rooted in the uncertainties of the subatomic world. The quantum and the cosmic are intimately linked, each dependent on the other to exist in the form we know. Consider for a moment that your own existence hinges on these delicate improbabilities. The particles in your heart and brain obey these strange laws. At every moment, within you, electrons jump in atoms, enzymes facilitate reactions by quantum quirks, and even the very sense of smell you have might involve electrons tunneling in receptors. We go about our lives unaware that the utterly bizarre is happening in every cell. Yet here we are, large and stable, classical creatures, in a quantum-built body, marveling at the stars. It is as if nature hides its magic beneath a veil of normalcy, so we are free to live and wonder without being overwhelmed by constant paradox. But on nights like this, while contemplating the cosmos, that veil thins just a little. We remember that the ground of reality, the foundation of everything, is a mystery that goes beyond our full comprehension. Some have wondered if consciousness itself is tied to this quantum strangeness. Could it be that the mind, in its ability to jump from one thought to another, or in the feeling of free will, has something quantum about it? This is speculative, and yet it's intriguing to think that the gap between an intention and an action might be a kind of quantum leap. Whether or not that is true, we do know that our brains operate with electrical impulses and chemical signals that are ultimately governed by those same microscopic rules. So in a way, the thoughts you have, even this very experience of calm reflection, are enabled by subatomic particles doing their quantum dance in your neurons. We are quantum beings as much as we are cosmic beings. The dual nature of particles, behaving as both material and immaterial, has a philosophical echo. We too are flesh and spirit, physical yet filled with intangible feelings. The quantum world shows us that reality is not simply material or energy, but something more subtle, something that can manifest as tangible matter or as spread out potential. Similarly, within us, there are tangible aspects like our bodies, and intangible ones like dreams, thoughts, and consciousness. Perhaps the line between what is physical and what is not is more blurred than we think, just as the line between particle and wave is blurred for a photon. In the smallest spaces, the categories we take for granted break down, inviting us to embrace uncertainty and paradox as fundamental parts of nature. All of this might sound bewildering, but in the gentle context of our cosmic journey, it can also be quietly wondrous. It tells us that there are layers of reality stacked in ways our senses alone cannot reveal. If the cosmos were a grand mansion, our everyday experience is like living in just one beautifully furnished room. Science has opened doorways to other rooms, showing us that beyond our normal view, there are wonders. Some behave like funhouse mirrors, where up can seem down, or like secret passageways connecting distant halls. It's as though the universe enjoys a bit of playful mystery, keeping surprises tucked away in the very structure of existence. As our minds absorb these reflections, let us gently step back from the quantum world. We zoom out from the tiny atoms and return to the realm of the visible and tangible. See in your mind's eye the scene expanding, from subatomic particles to atoms, to grains of sand, to a human hand, to the entire person, to the environment around, and finally back to the open night sky overhead. The stars still sparkle calmly, seemingly unchanged by the bizarre truths we uncovered beneath the surface. And indeed, for ancient travellers and poets, these details were unknown. What they experienced was a sky of reliable patterns, guiding lights that turned with the seasons, year after year, faithful and familiar. So now, as if rising from that subatomic reverie, we turn our attention back to the human scale under the open sky, to the wisdom of those who came long before, who navigated the cosmic seas without ever knowing the word quantum, but who connected to the cosmos through stories and practical knowledge of the stars. Long before modern instruments and charts, humans learned to read the night sky as if it were gentle instruction from the cosmos. Imagine a vast ocean centuries ago. A Polynesian voyager stands at the helm of a canoe carved from an ancient sacred tree. All around is the dark water below, and above, an astounding sprawl of stars. There is no land in sight, only the swell of waves and the dome of heaven. Yet this voyager is not lost. As the sun set, they noted the first star to appear on the horizon, a familiar friend marking the direction of home. Through the night, they navigate by the rising of specific stars, each guiding them along a memorized path across the sea. With no compass but the sky itself, they trust in a map written in starlight, passed down through generations. In the gentle rocking of the canoe, one can almost feel how the navigator's senses extend beyond the boat. The sailor feels the pattern of swells against the hull and the cool wind shifting, while overhead the constellations slowly rotate. They carry in their mind a starry compass, a mental chart of where key stars rise and set along the horizon. As one guiding star climbs high and drifts westward, the voyager's eyes move to the eastern horizon for the next star that will take its place in guiding the way. All through the night, this relay of stars keeps the canoe on course. The voyager might softly chant an ancient song that names each star and its role. The melody itself, a tool to remember the route. There is serenity in this wayfaring. The ocean and sky are not adversaries, but trusted companions on the journey. The North Star, called Polaris, has long been a steady beacon for travellers in the northern world. In the sky it barely moves, holding nearly still while the other stars wheel around it. For sailors and wanderers, this fixed point offered reassurance, a cosmic lighthouse shining no matter how dark the night. Many a traveller has looked up, found Polaris, and felt a wave of relief, knowing the direction of north with certainty. In the southern hemisphere, where Polaris cannot be seen, navigators turn to the Southern Cross, a cross-shaped grouping of stars, and the two pointer stars near it to infer the location of the South Celestial Pole. Even without a single bright star to anchor the sky, the pattern of those stars provided a reliable guide. No matter where one stood on Earth, the sky was a compass for those who knew its secrets. These techniques were often safeguarded and taught within families or guilds of navigators, and in some cultures the knowledge was considered sacred. After all, the ability to cross a vast ocean and return was a matter of life and death. It required not only skill, but a profound relationship with nature. The navigator had to attune themselves to subtle cues, the color of the twilight, the direction of swells which might hint at faraway land, the flight paths of birds at dawn, returning to roost on islands over the horizon. Each sign was read in conjunction with the stars. It is a testament to human ingenuity and trust in the cosmos that people voyaged for thousands of miles this way, long before sextants or modern navigation tools. Consider an image of an elderly Pacific Island wayfinder teaching a young apprentice under a dome of brilliant stars. They lie on their backs in a canoe moored in calm lagoon waters, the elder's weathered hand pointing out the star paths. With each gesture, they recount a story, how this star was named for a particular ancestor, how that constellation looks like a fish hook used by a demigod to pull up islands from the sea. The apprentice listens and watches, eyes tracing the invisible lines drawn by the teacher's words, connecting star to star. They feel the warm night air and hear the gentle lapping of waves, absorbing the knowledge that will one day keep them alive on the open ocean. In teaching navigation, myth and practical wisdom merge seamlessly. The stories serve as both mnemonic and moral, embedding important navigational cues in a narrative that can be easily remembered and passed on. And indeed, for people everywhere, the night sky became a grand tapestry of stories. Long before television or books, our ancestors looked upward for storytelling inspiration. They saw figures of legend among the stars, heroes, monsters, gods, and animals, their dramas playing out night after night in slow motion as the changing seasons shifted which stars were visible. The patterns we call constellations were like a global picture book with different cultures drawing different pictures from the same points of light. What one group saw as a great bear, another imagined as a mighty hunter, and yet another as a celestial canoe. For example, in Greek mythology, the constellation Orion is known as a great hunter with a shining belt of 3 stars. He chases eternally across the sky, accompanied by his faithful dog, the star Sirius, brightest of night. To the ancient Greeks, Orion's setting, when he dipped below the horizon, signified the time of year when scorpions, represented by the constellation Scorpius, on the opposite side of the sky, rose, as if the scorpion that once stung him still pursues him among the stars. Meanwhile, many Pacific Island cultures saw a different picture in some of those same stars. In one Polynesian interpretation, Orion's belt and nearby stars form the outline of a great canoe, reflecting their seafaring life in the heavens. The Pleiades star cluster is another celestial wonder wrapped in story. To the naked eye, in a clear, dark sky, one can see 6 or 7 tiny stars clumped close together, like a little sprinkle of diamonds. Almost every culture noticed this cluster and wove tales about it. To the Greeks, these were the 7 sisters, daughters of a Titan, pursued by Orion or placed in the sky to escape grief, depending on the tale. In Maori tradition in New Zealand, the cluster is called Matariki, and its rising in winter marks the beginning of the new year, a time of remembrance and planting for the coming spring. In Japanese, they are Subaru, a name you might recognize, as even a modern car brand pays homage to the cluster's unity of stars. In many Native American traditions, there are stories of 7 siblings or friends who became those stars. One beautiful tale from the Cheyenne people speaks of 7 children who fled to the sky to escape a bear, forming the Pleiades, and the bear became the nearby Big Dipper stars. Such stories, while varied, show how universally this little cluster captured human imagination. when people far apart in time and space all felt compelled to explain the same pinwheel of tiny stars with narrative. It underscores a shared human desire to connect the dots of the sky into something meaningful. The Milky Way itself, the ribbon of diffuse light arching overhead, was often interpreted as a path or river. Some called it the River of Heaven, imagining that souls travelled along it to the afterlife, or that gods crossed it as a shimmering bridge. Others saw it as spilled milk from a goddess, or the strewn hay from a celestial horse's feeding sack. In a Chinese tale, it is the Silver River that separates two lovers, the star Altair, a cowherd, and the star Vega, a weaver girl, who are allowed to meet only once a year when a bridge of magpie birds forms across the Milky Way, allowing them to reunite. That story is still celebrated on a summer night each year, when people look up and remember the lovers. Meanwhile, in a different land far away, some Aboriginal peoples in Australia look at the Milky Way not by its stars, but by its dark patches. Against the glowing starry band, they see the shape of a great emu stretching across the sky. The emu's head is a coal-black nebula near the Southern Cross, and its body follows the Milky Way's misty path. This sky. Emu is woven into their traditions. When it appears in a certain posture at dusk, it signals the season to gather emu eggs. The dark voids of the galaxy become a giant bird in their imagination, connecting the cosmos to their way of life. This creative vision shows that human imagination finds meaning not just in stars, but in the darkness between them. Through stories, the stars became more than just lights. They became reminders of lessons, of morals, of cycles of nature. A constellation representing a hero might remind people of courage during difficult times. One representing a farming tool or animal might signal when to plant crops or hunt game. The sky was a calendar and a compass combined with a storybook, as useful as it was inspiring. The myths served multiple purposes: entertainment, moral guidance, and practical knowledge, all encoded in one. Consider also the experience of a child in ancient times, looking up on a clear night while an elder pointed out the constellations and recounted their tales. The child's eyes might move from star to star as the figures come alive in imagination, perhaps seeing the mighty shape of Orion or the arc of a scorpion's tail. They hear how those stars came to be, maybe a story of love or bravery or transformation. In those moments, the child is not only learning the sky's map, but also absorbing a sense of belonging to a larger narrative. They learn that the same stars were watched by their ancestors, that the same tales are passed down, and thus they too are part of this continuity. The stars tie generations together, as each retelling of a constellation story rekindles the memory of those who first told it. All the while, the night gently turns. The earth rotates and new stars rise in the east, while others set in the west, making the sky dynamic. Over months, the constellations shift with the seasons. Our ancestors noticed this, and the sky became their seasonal clock. The appearance of certain stars at dawn or dusk signaled planting time or harvest, the migration of herds, or the flooding of rivers. For example, the ancient Egyptians watched for the rising of Sirius just before sunrise, which heralded the annual flooding of the Nile, crucial for their agriculture. To them, this star was linked to the goddess Isis and the cycle of life, death, and rebirth of the land. Thus, mythology, agriculture, and early astronomy intertwined. Navigators, storytellers, farmers, and priests alike studied the sky, albeit with different aims. But whether they sought to find their way across open ocean, to explain the mysteries of existence through tales of gods, or to predict the change of seasons, they all treated the sky as a trusted guide. It loomed above as a constant presence that anyone could observe. Over generations, careful observation and rich imagination turned into traditions of knowledge. Even today, there are those reviving and practicing these ancient arts. In the Pacific, navigators have begun again to sail voyaging canoes without modern instruments, trusting the stars, waves, and winds as their ancestors did, proving the old ways still hold. Such journeys are as spiritual as they are technical, reaffirming a bond with nature and heritage. We might think in modern times that we have moved beyond those star stories, replacing them with scientific fact. But on a quiet night, even now, if you gaze long enough, you might find your mind drifting into old patterns, seeing the shape of a hero here, a mythical creature there, or recalling a legend you heard once about a constellation. Our fancy for stories never truly leaves us, because it's woven into how we perceive patterns and meaning. Science, in its own way, has continuity with these ancient impulses. Both are driven by curiosity and the urge to find connections. Where an ancient mythmaker connected stars to craft a tale, a modern astronomer connects data points to form a theory. Both are creating narratives to describe and predict the workings of the world. One through imagination, the other through mathematics and observation. Under the stars, the boundary between practical navigation and spiritual journey often fades. Many cultures believed that gods or spirits literally inhabited the stars, or that ancestors became stars when they passed on. A voyager might feel that their ancestors were watching over them in the sky, guiding them along. The night sky could be both compass and cathedral, a place of direction and of worship. Even today, away from city lights, one can feel a natural reverence gazing up. It is as if something in our very old memory recognizes the importance of that view. We might not remember the specific star lore of our distant forebears, but the feeling of wonder and respect is ingrained. Now, as the ancient stories and methods swirl in our thoughts, we can appreciate how human understanding of the cosmos evolved. We moved from seeing patterns and telling tales to measuring and hypothesizing. Yet we should not think of it as discarding one for the other, but rather adding layers. The starry sky that once solely told myths now also tells us about galaxies and physics, but the myths can still live on in our cultural heritage. In a way, the cosmos has always been a canvas for our minds. What changed over time was the brushstrokes we used, at first painting with mythic imagination, later with scientific reasoning. Ultimately, both pictures reflect our desire to engage with the cosmos. Humanity's relationship with the stars has been both practical and poetic. The night sky guided our voyages and also our dreams. With those dreams in mind, we drift onward, from the tales of old to the ways we seek understanding today, blending myth and science in the ongoing story of our connection to the universe. For centuries, myth and science have danced around each other like twin stars orbiting a common center, the human desire to understand. Myths were our first brave attempts to explain the bewildering and the beautiful. Before we had equations, we had stories. When thunder roared, we spoke of gods. When comets streaked the sky, we imagined dragons or omens. These tales were not foolish. They were our early wonder given narrative form. They comforted us, taught us, and piqued our curiosity. They also spurred practical knowledge. Ancient peoples marked the passage of seasons by the stars. They built great circles of stone and pyramids aligned with celestial events. Think of Stonehenge in England catching the sunrise of midsummer, or the pyramids in Egypt aligned to north like giant compasses, or the temples of the Maya precisely tracking the cycles of Venus. Such structures required careful observation and record-keeping, an early scientific mindset inspired by the skies. Even without modern instruments, our ancestors mapped the heavens with remarkable accuracy, blending their mythic narratives with empirical timing. The sky was their textbook and their scripture both. In truth, the boundary between myth and science is porous. Think of the ways we often personify scientific concepts. We talk about the angry, red planet Mars, or the elegant dance of binary stars, or the generous sun giving life. These are metaphors, little mythic flares in our language, acknowledging that there is poetry even in facts. We name constellations after ancient heroes and planets after old gods, as if deep down we know that myth and science are both part of one continuum of meaning. We even send our scientific creations to the heavens bearing mythic names, rockets named for Saturn, spacecraft named Juno or Apollo, rovers named for goddesses of dawn. It's as though we cannot resist linking our newfound knowledge back to familiar stories, because those stories are our cultural heartbeat. Consider how every scientific theory begins as a spark in the mind. Newton watching an apple fall and pondering if the moon falls around Earth in the same way. Einstein picturing himself riding a beam of light. These pivotal moments are acts of imagination. They became science after rigorous thinking and testing, but they started in the realm of creativity, not so different from dreaming up a myth. And like myths, sometimes scientific ideas sound incredible at first. The Earth moving around the sun, invisible forces of gravity, time dilating with speed, holes in space, swallowing even light. These could be plot points in a fantastical story, yet they are our reality, proven and accepted, but no less wondrous. In communicating these discoveries, scientists often must become storytellers themselves, crafting narratives that guide others to understand truths that are not immediately visible. Our modern explanation of the universe's origin, the Big Bang, is itself a kind of creation story. Instead of gods forging the world, we have a tiny, hot seed that expanded outward, cooling and spawning galaxies and stars over billions of years. Instead of a single generation of deities, we have multiple generations of stars giving birth to heavier elements in their fiery cores and spreading them in supernovae, from which new stars and planets form. We tell of how our sun and earth coalesced from a swirling nebula, how life sparked in the oceans, how consciousness lit up in creatures that could then look back and tell the story. This grand narrative is pieced together by evidence and reason, but we string those pieces into a timeline that humans can grasp, a story with a beginning, however abstract, a dramatic unfolding and ongoing chapters. There is even a hint of fate or destiny in the way conditions had to be just right for life, echoing anthropic musings that the universe in some way knew we were coming, though science would frame it as fortunate coincidence filtered by vast numbers. Yet science is careful. It reminds us that unlike fixed myths, its stories are provisional. If new evidence arrives, the story changes. Once, we thought the expansion of the universe might be slowing. Now we observe it's accelerating. So our cosmic story gained a new mysterious element: dark energy, an unknown force driving galaxies apart faster and faster. In mythic terms, one might call it an invisible, enigmatic spirit of expansion. In scientific terms, it's a puzzle to solve. Both ways, we acknowledge there is something we don't fully understand, and we give it a name so we can talk about it. Dark matter and dark energy, even the act of naming them with the word dark, shows that we are casting about in metaphor to describe what is essentially the unknown. These are our modern mysteries and wonders, as profound as any ancient riddle. We have detected their influence, yet their true nature remains elusive. It is as if the cosmos is keeping secrets, ensuring that wonder and discovery are never-ending. Just as myths spoke of hidden forces and realms, science now speaks of unseen ingredients of the universe that challenge our understanding. We give them names as placeholders, but they humble us, reminding us that for all we have learned, there is vastly more we do not know. Perhaps future generations will unravel these secrets, turning the unknown into the known and finding new mysteries beyond, continuing the grand story. Imagination fuels both art and science. A cosmologist imagines how space might curve and warp, just as a painter imagines new worlds on a canvas. When we build telescopes to peer deeper into space, it's like adding new chapters to our cosmic story, filled with images that astonish us. Galaxies colliding, nebulae glowing with newborn stars, black holes with swirling disks like cosmic whirlpools. We often give these sights poetic names too: the Pillars of Creation, the Eye of God Nebula, the Butterfly Nebula, as if to tame the raw data with a touch of familiar beauty. The reality of them is natural phenomena, but our perception layers meaning and wonder on top, much as it always has. Think of how star lore and science education coexist today. A teacher might start a lesson by recounting how the Navajos see the Milky Way as a path of spirits, and then segue into how it is composed of billions of stars. The interplay makes learning rich and keeps our sense of wonder intact. We do not have to choose one or the other in our hearts. We can appreciate the scientific explanation while still feeling the poetry of the older tale. In fact, sometimes knowing the science deepens the awe. When we learn that the colours of a sunset come from light scattering, we might simultaneously recall a legend of the sun being painted by a god's hand, and hold both thoughts with a smile, one foot in factual understanding, one in imaginative appreciation. Modern storytelling continues to expand our cosmic imagination. Through books and films, we conjure scenarios of interstellar travel, encounters with alien life, journeys through time. These are our new myths, projected into the future instead of the past, but they serve a similar role. They let us explore possibilities in the safety of imagination. What if we could sail among the stars as ancient mariners sailed the seas? What civilizations might exist on worlds circling those distant suns? These fictions spark the public's interest in actual science. Many scientists trace their inspiration back to a childhood book or movie that ignited their passion for the stars. In that way, storytelling propels understanding forward. Dreamers imagine it, and later someone tries to build it. Indeed, the boundary between fantasy and reality is porous. Humans dreamt of flying to the moon long before rockets existed. And then one day, those dreams guided us to set foot on the lunar surface. What was magic became science. As we stand at the shore of the cosmic ocean, we can wonder which of our current stories, perhaps journeys to Mars or voyages beyond our solar system, will be the next to come true. Every great endeavor is born from a narrative we believe in. Even within the practice of science itself, the way we share discoveries often takes the shape of story. When cosmologists talk about the early universe, they describe phases with evocative names: first light, cosmic dawn, the era of recombination, cosmic inflation, terms that sound almost mythic. There's drama, initial chaos, rapid expansion, cooling, battles between matter and antimatter, the triumph of matter, the formation of structure, star birth and star death. It's hard to escape a narrative structure because our human brains seek patterns and arcs. Good scientists remain vigilant about facts and evidence, but they use narrative as a tool to communicate and to hypothesize. In doing so, the cosmos becomes not just data points, but an unfolding saga we are part of. Throughout history, there have been moments when myth and science directly collided or converged. When Halley's Comet returned in 1910, some people feared it as a bad omen, as in the old myths, while astronomers calmly calculated its trajectory. When we first saw the surface of Mars through telescopes, some imagined canals built by Martians, blending observation with fanciful interpretation. That particular imaginative leap turned out incorrect, but it led to countless stories that in turn inspired real scientific searches for life on Mars. Even today, when a scientist ponders multiverse theories, countless unseen universes with different realities, one might say we are touching ancient ideas of innumerable other worlds or realms akin to myths of other dimensions or spiritual planes. If the multiverse exists, then reality is layered beyond comprehension. Each universe a bubble with its own stars, and perhaps its own forms of life, an endless foam of creation. It remains a scientific speculation, but it serves as a profound reminder that however far we push our understanding, there may always be more, a greater context we have yet to glimpse, an ever wider horizon of existence. In that sense, the daring leap of vision is similar across ages. We continually expand our conception of what might be, guided by both wonder and reason. There is a sort of harmony in acknowledging both sides of our nature, the analytical and the imaginative. Alone, science can become dry, and myth can become baseless. Together, they enrich one another. When the night sky makes us feel something profound, that is the domain of poetry. When we then measure the spectra of starlight to find their elements, that is science. Feeling and understanding, both are essential to a full relationship with the cosmos. We are not robots cataloguing stars, nor are we only dreamers ignoring facts. We are a blend, a species that uses mind and heart together. So as we gaze at the stars tonight in our journey, we carry with us both ancient and modern wisdom. We can admire Orion as the hunter of legend, and simultaneously as a giant assembly of stars hundreds of light years away, including red Betelgeuse nearing the end of its life, and blue Rigel shining hot and young. Knowing these facts doesn't diminish the constellation's allure. If anything, it adds another layer of meaning. The cosmos grows more complex, and yet more personal the more we learn. Each discovery is like finding a new piece in an endlessly rich story. Let us also reflect on ourselves as storytellers. We have been doing it this entire time. This very narration is a form of storytelling, weaving facts and reflection into a narrative to share with you. In telling the story of the universe, we are engaging in one of humanity's oldest pastimes, passing knowledge and wonder from one person to another. Whether around a campfire or through the medium of a screen or speaker, the essence remains. One being says to another, "Listen, I have seen something amazing. Let me share it with you." In this way, each of us becomes both student and teacher of the cosmos, inheriting wonder from those before us and gifting it to those after us. As we prepare to explore the next realm of experience, the night has deepened and the outer world grows still. It is a natural time to turn inward. Let's hold close this union of myth and science, of imagination and reason. They will accompany us as we turn inward now, to the realm of dreams and inner exploration, where the stories we tell meet the stories we live, and where the boundary between the universe out there and the universe within grows ever thinner. Night is the domain of dreams as well as stars. As the body rests and the conscious mind dims, the inner cosmos of imagination awakens. It is not uncommon for our dreams to carry us to the stars. Have you ever dreamed of flying, weightless and free? Perhaps in one dream you step off your doorstep and find you are walking on the moon, the grey dust soft beneath your feet, and the earth glowing in the black sky above. In another, you might float in a small boat on a cosmic ocean, its waters made of stars and galaxies, gently rowing through constellations as though they were islands. In dreams, the laws of physics loosen. We can breathe underwater or soar through space, guided by subconscious whims. The cosmos that we study by day can become a playground of symbols and emotions by night, as our minds weave personal narratives using the raw materials of our experiences and aspirations. Sometimes, the boundary between a dream and a story we tell consciously is thin. In a way, dreams are our mind telling a story to itself, trying to make sense of feelings and observations in a language of metaphor. A person deeply passionate about the stars might dream of meeting an entity made of stardust, or of sailing a celestial sea on a ship of light. A scientist wrestling with a hard problem might dream of a fantastical scenario that, upon waking, inspires a real solution. History holds remarkable tales of discoveries gleaned from dreams. One chemist, it said, saw in his sleep the image of a serpent biting its own tail, a symbol of wholeness, and it revealed to him the ring shape of a molecule, the long-sought structure of benzene. And as a teenager, a young Albert Einstein dreamed of sledding down a steep mountainside at the speed of light. In that dream, the starlight around him shifted to brilliant colours as he raced, leaving him with a haunting wonder that later blossomed into insights about light and time. Our nighttime dreams often borrow from the same well as our waking stories. The archetypes, the hero, the journey, the mystery, appear in both, simply dressed differently. In a dream, you might not remember the exact figures from a myth, but the essence could be there, travelling through darkness hoping to find light, encountering something fearsome and finding courage, or seeking knowledge and receiving a revelation. These universal story patterns play out behind our closed eyes, just as they do in our literature. It's as if humans are natural storytellers even in sleep, each night composing little plays in the theatre of the mind, and often the stage set is cosmic: dark skies, distant lights, unearthly landscapes. The space in which dreams occur is boundless, much like the outer space we gaze into. Perhaps this is why the quiet of night and the twinkle of stars are so conducive to drifting into dreams. The external environment and the internal state harmonize. There is also the phenomenon of daydreaming. You might find yourself staring out a window, mind wandering beyond immediate tasks, and suddenly you're imagining other worlds or future adventures. These gentle reveries are like controlled dreams, and many great ideas have sparked in such moments. A rocket scientist might have once been a child daydreaming about riding a rocket. An astronomer might have been a youngster imagining alien sunsets on far-flung planets. Storytelling often begins in these private musings long before it is shared. By the time a writer or scientist puts pen to paper, they might have lived 100 imaginative journeys in their mind. Storytelling itself is a kind of dream that we agree to share. When you hear a story or watch a movie, you willingly suspend your everyday perspective and invite a new vision. Part of you knows it's fiction, yet another part reacts emotionally as if it were real, much like in a dream. A well-told story about the cosmos can make your heart race at an astronaut's bravery or ache at an alien world's beauty, all while you're snug in bed or curled up in a chair. Through stories, we collectively experience scenarios we never could individually. We simulate life among the stars, time travel, meeting beings from other worlds, exploring the unknown, all without leaving home. These experiences shape our cultural understanding of the cosmos. Even if they are invented, they prepare our minds to accept or even search for similar wonders in reality. Think of a time you heard a bedtime story about the stars. Perhaps a parent or grandparent pointed out the Big Dipper and then told you how it pours out the dew at night, or shared another fanciful fable. As a child, you likely absorbed that with wide eyes, letting it colour your perception of those stars. As you grew and learned the scientific explanations, that early enchantment might have faded in literal accuracy, but it probably left an emotional imprint, a fondness for the stars that remains within you. This is how storytelling contributes to cosmic understanding. By engaging our emotions and sense of wonder first, it ensures we care enough to pursue the facts later. We often need to love something before we invest in truly knowing it. Stories make us fall in love with the universe. Even now, this very journey we are on, speaking softly about the universe in a meditative narrative, is a form of storytelling. It mixes fact and reflection, reality and imagery, in a way not unlike a lucid dream. You are awake, yet you allow these words to paint scenes in your mind. The ancient navigator at sea, the drift through atomic worlds, the ancestors under constellations, and perhaps even yourself in a dream floating among stars. You might find that these images stick with you, and later when you look at the night sky, they resurface, enriching what you see. You may recall that feeling of being connected, or the notion that those stars have stories within them, or that within your very being is the same substance as the stars. That is the subtle power of storytelling and imagination. It layers additional meaning onto reality, making the universe not just a collection of objects, but a living experience for us. In the grand tapestry of human knowledge, storytelling ensures that information is alive, accessible, and continuously reinterpreted. Scientific data becomes far more engaging when there's a narrative. Consider the way we frame the search for life on Mars as a story of exploration and hope, or the way we talk about the fate of the universe with a note of suspense Will it expand forever, fade to black, or perhaps cycle anew? These narratives help us grapple with abstract concepts on a human level. Without them, raw facts might slip from memory, but a good story lingers. Many of us might forget the exact temperature of the sun's surface. It's extremely hot. But remember the catchy line from an old song that the sun is a mass of incandescent gas, a musical story of sorts. Memory and meaning are tied to narrative. There is also a deeply personal side to this. Each of us has our own cosmic story, a series of moments or experiences through which the universe became meaningful to us. Perhaps it was the first time you saw the Milky Way band on a camping trip, feeling suddenly small and awestruck. Or perhaps it was when you learned about the planets in school and imagined what it would be like to visit them. Maybe it was the moment you realized a loved one who passed away is, in a sense, returning to the stars, and that thought gave you comfort. These events weave together into your personal mythology of the cosmos. We might not often share these inner stories, but they quietly guide how we relate to the night sky and the very idea of the universe. Dreams and stories can also act as bridges across time. An astronomer today, using sophisticated telescopes, may still recall the myths that once explained the constellations she studies, aware that she's part of a long continuum from mythic storyteller to scientist. In dreams, time and space often mix. You might walk in a prehistoric landscape and then step into a futuristic spaceship in the next moment. Similarly, in storytelling, we traverse timescales with ease. We recount the birth of the universe and then imagine future galaxies millions of years hence. Our minds are not bound in the way our bodies are. They roam free, connecting past, present and future, probing both what was and what could be. Some say that reality itself might be a kind of story, a narrative woven by the cosmos. Whether or not that is true, it is undeniable that we make sense of reality through narrative. The cosmos gives us events, and we string them into cause and effect, into history and prediction. In doing so, we find coherence and meaning. This is not to say we fabricate what is not there. Rather, we find the threads of connection that do exist and follow them like following a plot. The story of how stars recycle material into new stars and planets is one such thread of connection. The story of how life evolves and becomes aware is another. When we share these stories with each other, especially in compelling ways, we collectively deepen our understanding. A fact that could be dry, like we are made of star stuff, becomes profound when framed as a story. Long ago, stars died so that you could be born. They exploded, scattering the elements that now form your body. It's the same truth, but delivered in narrative form. It touches a place in us that pure data cannot. In the quiet of a story or a dream, we often confront the big questions naturally. Children listening to a tale may suddenly ask, "Why are we here?" Or, "What are stars made of?" A bedtime story about the man in the moon might lead to wondering if anyone really lives on the moon. These gentle prompts show how stories open doorways to curiosity. Similarly, an adult might watch a science fiction film and come away pondering the nature of consciousness or the fate of civilizations. Thus, storytelling doesn't just feed us answers. It stirs up questions in an inviting way. It sets our minds on journeys of their own, which is exactly how understanding deepens. As we drift through this reflective night, allow yourself to value your own inner stories. The memories, dreams, and questions you have about the cosmos are part of your unique relationship with it. No one else has the same set of experiences or the same inner universe as you do. In a sense, each person's consciousness is a cosmos unto itself, rich with memories which are like stars, feelings like nebulas of glowing emotion, and thoughts like comets darting in and out. We each carry a miniature sky inside, one filled with constellations of our experiences. This realization brings us to a thought that seamlessly ties the outer and inner together. The idea that the universe we observe and the universe within us might not be entirely separate. For all the vast distance and difference in scale, there is a reflective symmetry in patterns and in our pursuit of meaning. It is time now to explore that idea further. That inner space, the realm of mind and soul, is in many ways a mirror to the outer space of stars and galaxies. In that exploration, we find perhaps the deepest connection of all. Inner space and outer space, two grand frontiers that at first seem entirely different, actually reflect one another in uncanny ways. Look up at the night sky. You see countless stars scattered across the vast darkness around you. Now close your eyes and look within. You find thoughts and memories twinkling in the darkness of your mind. There is a structure to the cosmos at every scale. Galaxies form filaments and clusters, arranged almost like a cosmic web, with great voids between. Curiously, if you look at neural networks in a brain, the pattern can appear strikingly similar. Neurons connecting in complex webs, transmitting signals across emptiness. One could almost imagine that a brain cell and a galaxy, different by trillions upon trillions of times in size, rhyme with each other in form. It might be coincidence, or it might hint at a deep principle of nature repeating patterns, as if the universe likes to reuse a beautiful design in varied contexts. Think of the numbers. There are on the order of 100 billion stars in our galaxy, and coincidentally, about 100 billion neurons in a human brain. Is it just chance, or does it speak to the vast and endless potential for complexity, both out in space and inside our skulls? Perhaps it is merely a poetic parallel, but it fuels the imagination to think that consciousness and cosmos might be parallel processes. Each of us carries within our head a structure as intricate in its own way as a galaxy. When you ponder the stars, there is a galaxy of neurons in your mind, firing patterns that correspond to that thought. It's as if one vast system is reflecting on another. Our ancestors had an intuition about this mirroring. As above, so below, they would say, suggesting that the patterns of heaven are echoed on earth. In modern understanding, we see echoes of that sentiment in fractals and repeating natural designs, spirals swirling galaxies millions of light years wide, and similar spirals shape the shells of snails, the pattern of a hurricane on Earth, and even the twisting double helix of DNA. Spheres are the shape of planets, and also of cells and seeds. The pull of gravity makes planets round. The pull of surface tension makes a rain droplet round. Coincidence or cosmic rhyme? Such patterns remind us that we are not separate from the universe, but part of its continuous creativity. Consider your very body. It is composed of the same elements found across the cosmos. We often recall that we are made of star stuff, but think of it in detail. The iron in your blood was forged in the explosion of a supernova long before the Earth existed. The calcium in your bones was brewed in the belly of a star. The oxygen that fills your lungs each moment was produced by generations of plants under the sun's light. But the atoms of that oxygen were formed in ancient stars as well. In essence, your inner space, the matter that makes you alive, is literally the ashes of long-dead stars, given new form and life. When you contemplate that, the boundary between you and the cosmos becomes blurry. You are a walking universe in miniature, with pieces of galaxies and stars inside you, dancing to the rhythm of life. Even the processes within us echo cosmic events. The electrical impulses in our nerves and brain are akin to lightning, or the solar flares of the sun, scaled down to microscopic intensity. The heat in our bodies is a tiny echo of the nuclear fusion in stars, as we burn calories in a controlled biochemical fire to stay warm and alive. The water circulating in our veins and cells once cycled through ancient oceans and clouds, and perhaps comets that delivered water to the early earth. The salt in our tears and blood is from the primordial sea that nurtured the first life, an echo of the ocean that once enveloped all living things. And the sea's tides answer to the gravitational pull of the moon, linking our internal chemistry to the movements of celestial bodies. Our lives are tuned to cosmic rhythms. Day and night, governed by Earth's rotation, deeply affect our biology. In daylight, stimulated by the sun, we are alert. At night, under darkness and starlight, our bodies release hormones that invite sleep. We carry an internal clock, a circadian rhythm that is essentially the echo of Earth turning under the sky. The moon's cycles have been observed to sway the behavior of various animals, and maybe even our own moods. A subtle monthly rhythm that mirrors the moon's journey around us. Across seasons, as Earth orbits the sun, we experience changes in weather and length of days, which shape our inner emotional landscape and energy. Many people feel uplifted as spring returns and the world warms, or reflective in autumn as days shorten. These are inner experiences directly tied to cosmic motions. Contemplate also the depths of time. The universe measures time in billions of years. The spans of star lifetimes and galactic dances. Our human lives, by contrast, span mere decades, a fleeting tick in cosmic terms. But time is relative to the beholder. For a butterfly that lives only a summer, that season is a complete lifetime filled with sunshine and purpose. For an ancient star burning for 10 billion years, a million years might feel like a moment of its existence. We, somewhere in between, perceive years and centuries as significant stretches. Yet, in those brief years, we experience love, learning, and wonder enough to fill a universe. In this way, the ephemeral and the eternal coexist. Every short life is a microcosm of meaning against the backdrop of cosmic eons. Knowing how short our time is can make each day more precious, and knowing how long the cosmos endures can give us comfort that life and memory persist in some form. Even after we are gone, our atoms will rejoin the earth and sky, and time will continue weaving new tapestries. We thus partake in eternity, each of us a brief but beautiful theme in the endless cosmic symphony of time. Our lives are also part of cosmic cycles, in another sense. Many cultures talk of a circle of life, and indeed we see cycles everywhere. Day giving way to night, winter to spring, the phases of the moon, the rise and fall of civilizations. These cosmic rhythms and cycles of days, moons, seasons, and ages remind us continually that we are part of something much larger than ourselves. The cosmos also influences how we see ourselves in a more philosophical sense. We project human concepts onto the stars: love, war, heroism, fate. And the stars in turn influence our concepts by their very existence, challenging and expanding our understanding. We saw how mythmakers did this explicitly. Now scientists do it in a different way. We contemplate the eventual fate of the universe. Will it collapse, drift forever, or something else? And it informs our philosophies about permanence and change. We learn that even stars are born and die, and it comforts us that death is part of a natural cycle, even on the grandest scales. We realize Earth is not the center of the universe, and it humbles us, influencing religious and existential thought. It's a dialogue. We ask questions, the cosmos answers with discoveries, and those answers pose new questions in our minds. On a very personal level, many people use metaphors of outer space to describe inner feelings. We say, "I need space," when overwhelmed, as if a mental equivalent of a starry expanse is needed to feel free. We feel starry-eyed in love, as if filled with bright lights within. Deep sadness can feel like a black hole that nothing escapes. A burst of inspiration might feel like a supernova in the mind. These are poetic comparisons, but they show how entwined the imagery of the cosmos is with our vocabulary of emotion. It's as if our psyche borrowed the universe's language to articulate its own mysteries. These reflective connections between inner and outer extend even into how we search for meaning. We contemplate and personify the cosmos, and in turn those cosmic realities challenge our perceptions of meaning. We saw how myths personified planets as gods. Now the discovery of how small Earth is in the cosmic scale forces us to find meaning, not in being the center, but in being part of a vast community of worlds. The interplay goes on. We ask, we learn, and we adapt our inner worldview. Meditation is a practice that often explicitly unites inner and outer. Many meditation traditions encourage envisioning oneself as expansive as the sky, or to observe thoughts as clouds passing through the vast space of the mind. This analogy works because we innately sense that inside us is not just a cramped interior, but an open field of awareness. When you sit quietly and let go of the constant chatter, you may begin to feel your consciousness widen and become more still, like the night sky. Thoughts come and go like shooting stars or drifting clouds. In deep meditation, practitioners sometimes report a loss of the boundary between themselves and everything else, a direct encounter with that unity we have been contemplating. They might feel, even if briefly, that they become one with the universe, or that the universe is meditating through them. Even in a simple relaxation, you can gently taste a hint of this unity. For a moment, focus on the feeling of your body against the surface you rest on. Feel the pull of gravity which roots you to the earth. It is the same force tethering the moon in its orbit and guiding planets around the sun. Take a slow breath, and as you exhale, imagine any tension in your feet dissolving into the ground. Your toes and soles soften, and your ankles loosen. With the next exhale, feel your calves and knees release any tightness, your legs becoming comfortably heavy and warm. Breathe again, and let go of any holding in your hips and lower back. The earth is cushioning you. You can surrender your weight to it. Let your belly relax and your chest remain open as you breathe. Feel the steady rhythm of your heartbeat, steady and calm, like the gentle ticking of a cosmic clock within you. Allow your shoulders to drop, freeing themselves of the day's burdens. Your arms and hands rest easily at your sides, tingling with relief. As you breathe out once more, feel your neck and jaw unclench and relax. Your face softens and your eyelids grow heavy. From head to toe, a wave of ease flows through you, as if a stream of starlight were washing gently over your body, coaxing every muscle into rest. In a more everyday sense, simply closing your eyes now and taking a slow, deep breath can be revealing. With eyes closed, the visual outer world is gone, but you are not gone. You find yourself in a space of darkness, with perhaps soft glows of colour from your optic nerves, a faint, ever-present inner light. Your sense of touch still tells you where your body is, but your mind can also float somewhat free of those confines. In that darkness behind closed eyelids, you might imagine the night sky. You can place a star in your mind's eye, and it will appear. You can conjure the earth floating in space and see it with inner vision. This simple ability suggests that inner space can hold the outer space as an image, like a mirror reflecting it. The canvas of the mind is vast and capable of holding the whole cosmos in reflection. Now consider dreams again here. In a dream, your inner space creates an outer world for you to experience. It might be as boundless as the cosmos, or as intimate as a small room, but while it lasts, it feels real. The material of that world is your own mind, yet you walk through it as if it were external. What is this if not a hint that inner and outer are made of the same stuff in different arrangements? The waking world has consistency we share collectively, while the dream world is personal and ephemeral. But both appear to consciousness and can shape consciousness. Some philosophies, especially in Eastern thought, suggest that the waking reality too is a kind of shared dream, or that consciousness is the fundamental substance of which matter is a manifestation. In those views, everything is essentially happening within one universal mind, and our individual minds are like eddies in that great stream. Modern science doesn't endorse any specific metaphysical stance like that, but it's a poetic contemplation that resonates with the sense of unity we've been exploring. Even if one doesn't subscribe to such ideas, there's no denying the interplay. The material universe created the conditions for consciousness through life and evolution, and now consciousness in us examines and contemplates the material universe. It's a loop, like a serpent biting its tail, reminiscent of that dream image which revealed a truth. The universe and consciousness are entwined in a dance, each giving rise to new forms and understandings in the other. With this perspective, one might ask, is it the universe that dreams through us, or we who dream of the universe? Perhaps both. When you imagine distant galaxies or aliens or futures, the universe is imagining itself through you. When a star somewhere goes supernova, and its light eventually stirs awe in an astronomer's heart, the universe is experiencing its own grand event through the intermediary of that awareness. It's a poetic way to see things, but comforting in its symmetry. Our joys, fears, and aspirations might be seen as the cosmos having those feelings in microcosm. As our journey through narrative comes to a close, it is worth sitting for a moment with the immensity of what we've touched. We explored the far reaches of galaxies and the deep recesses of atoms. We sailed with ancient navigators and listened to the sky's stories. We contemplated logic and myth, drifted through dreams, and finally looked within ourselves as though peering into a cosmic mirror. Through it all, a single thread winds: connection. Everything is connected, perhaps not visibly or tangibly, but through resonance, pattern, and shared origin. It leads us to a gentle truth. The sense of separation is to some extent an illusion, and to be alive is to be a part of something vast, eternal, and yet intimately here in each moment. We have journeyed far in this exploration, sailing from the birth of stars to the depths of subatomic particles, from ancient myths to future dreams, from the outermost galaxies to the inner landscape of the soul. Through it all, a pattern emerges. Everything is interwoven. The atoms in our bodies link us to long dead stars. Our stories and our science together illuminate the same cosmos. Our dreams at night echo the creative forces of the universe. Even our solitary mind is a microcosm reflecting the whole. It is as if the universe has been holding up a mirror, and in it we see not only the cosmos, but also ourselves. And perhaps that mirror works both ways. When we peer into ourselves, we catch a glimpse of the cosmos. In recognizing this unity, we find a kind of comfort, a sense that we belong here, that we are a natural part of the grand design, as fundamental as a moon orbiting a planet, or a thought orbiting the mind. Now, gently bring your attention to your body, allowing the tranquility of your mind to wash over every part of you. Notice how you are supported by your bed or the ground beneath you, by the earth itself. The planet's gravity is like a caring hand holding you safely in place. Take a slow breath, and as you exhale, imagine any tension in your feet dissolving into the ground. Your toes and the arches of your feet soften, and your ankles loosen comfortably. With the next exhale, feel your calves and knees release any tightness, your legs becoming comfortably heavy and warm. Breathe again, and let go of any holding in your hips and lower back. The earth is cushioning you. You can surrender your weight to it. Let your belly relax, and keep your chest open as you breathe. Feel the steady rhythm of your heartbeat, steady and calm, like the gentle ticking of a cosmic clock within you. Allow your shoulders to drop, freeing themselves of the day's burdens. Your arms and hands rest easily at your sides, tingling with relief. As you breathe out once more, feel your neck and jaw unclench and relax. Your face softens and your eyelids grow heavy. From head to toe, a wave of ease flows through you, as if a stream of starlight were washing gently over your body, coaxing every muscle into rest. Finally, as you prepare to slip into the gentle refuge of sleep, release any remaining worries or thoughts. There is nothing you need to do now, and nowhere you need to be, except here in this peaceful moment. You are cradled by the cosmos itself, as you have always been. From the moment you were born, every atom in you has been kept in the delicate balance of forces that govern the cosmos. Gravity holds you to Earth and keeps the Earth circling the sun. Electromagnetic forces keep your atoms together and also generate the light by which we see the stars. Nuclear forces lit the stars that made the elements that became you. The universe has collaborated for billions of years to bring you here now. In a very real sense, you are the universe, in one of its many creative and conscious forms, saying hello to itself, feeling wonder at itself. So, rest now in this knowledge. The cosmos stretches far beyond, full of mysteries and marvels, and it also curls up inside your very being. The journey of discovery is endless, but there's no rush. We have eternity, in a sense, each of us playing our part for a time. As our spoken journey ends, the real journey goes on in every moment, awake or asleep. We close our eyes now on the outward scene, but the inner universe will light up with its own stars in our dreams. May your dreams be gentle and filled with the quiet grandeur of the cosmos. And when you wake, may you carry a bit of this starlit peace into your day, remembering that beyond the hustle of life, the cosmos and your soul move together in an ancient and endless dance. Good night and sweet dreams under the eternal sky above.